Station. Okay, can you see my screen?
Yes.
Okay, awesome. So everybody, thank you for joining the Decarbonization Showcase run jointly by GC Ventures or GC and Deep Tech Showcase. So today's agenda, we'll just have some opening remarks from Deep Tech Showcase, GC, and then the panel discussion, which would end around 1:30, 1:35 Eastern, give or take. And then we'll jump into the pitch sessions. So the first one will be around 1:30 to 2:30, and the second one from 2:30 to 3:30 Eastern. So just a little bit about Deep Tech Showcase. We have a vision to bring deep tech to the market by leveraging the power of the community. This community consists of startups, tech scouts from the government and corporations, as well as investors, all of whom want to connect with each other for various reasons. Obviously, the startups would like access to capital and partnerships to get their company into the next step. Tech scouts from the corporations and government looking for innovative solutions to challenges they might face, or strategic investments, or pilot contracts, things of that sort, partnerships. And investors, of course, are looking for deal flow. So the main way we anchor this ecosystem are through monthly events by an industry theme. For example, this event has a theme of decarbonization technologies. We just hosted an event a couple weeks back on space technologies. In a few weeks, we'll have one on computing technologies and so on. They run the gamut from energy to advanced materials to aerospace and defense to space to everything in between. And at these events, these startups pitch to a panel, an audience of tech scouts from government and corporations, as well as investors. Between our events, we send some profiles of our client companies to the stakeholders, that is the investors, corporations, and government, who turn to us to scout specific tech. And if there's interest in that company, we create a warm introduction and business follows. Here are just some of our upcoming events. So we have the Future of Computing Showcase on November 29th, and then an Aerospace and Defense Showcase on January 25th of next year. We hope to see you all there. And just a quick word from our sponsor, if you will. So Eagle Point Funding is the parent company of Deep Tech Showcase. So I just want to give a little bit of a shout out to what they're doing. Essentially, Deep Tech Showcase helps companies on the business development side of things, but Eagle Point Funding helps companies win federal grants and contracts for R&D funding. So they're very familiar with the federal funding system, and they work with a wide range of agencies, as you could see from the logos on the bottom. Many of them for the DoD, so a lot of it is dual use tech, but we also have energy tech and everything in between. And they help scout out funding opportunities from the wide range of agencies that have funding opportunities available, and help companies apply for them. And one of the differentiators that they have is they're really good at crafting a story about a company's technology in a concise and compelling manner that can make the application for the federal funding more appealing and viewed more favorably by the evaluators, and to increase the chances of getting an award. So if you're interested in learning more about Eagle Point Funding and the federal funding opportunities that are available, or just about Deep Tech Showcase and want to learn about working with either of us or both of us, I highly recommend reach out to Max Frischman, who's the Chief Business Officer of Eagle Point Funding. His contact info is on this slide, and I will post it in the chat after I'm done with this presentation. So after the panel discussion, we're going to have our first session with the following companies. And then following them, we'll have the next batch of companies pitching. And with that, I will yield the time to Lisa and Tony and let them tell you a bit about GC and GC Ventures, and also get into the panel discussion.
Great.
I'm gonna
Thanks,
let you
Anthony.
share. I'll let you share screen.
Thank you. So I'm going to hand it over to Tony Sun, who's going to give you a brief introduction on GC Ventures, and then we'll hop into the panel discussion.
All right. Yeah. Thanks, Lisa. Thanks, Brian. Can you guys all see my screen?
Yep.
Great. Yeah. Thanks, everyone. This is Tony Sun, so Director of CVC at GC International. So together with my colleagues, Lisa, Gerald, and also Elena, who you will likely see virtually here today. So we run the North American operation for GC Ventures. So GC Ventures, we are the CVC arm for PTT Global Chemical, or GC in short. So we are a chemical company with headquarters in Thailand, but a global footprint. So we invest as a venture team, or we invest in early stage opportunities that can fundamentally address one key question: how to make chemicals in a sustainable way. Advanced materials, circular economy, decarbonization, and digital platforms are the 4 areas that we spend most of our time in. So for those who are not familiar with GC, so we are a leading chemical company in Asia with a wide product portfolio ranging from refinery commodity to performance materials. So we take pride in serving our customers by a strong sustainability mindset and also practices. So according to Dow Jones Sustainability Index, so GC is ranked as world's #1 in the chemical sector 4 years in a row so far. So more specifically, at GC, we have our own decarbonization goals. So for scope 1, 2 emissions, our goal is to reduce 20% by the year 2030 and then attain net zero in 2050. For scope 3, our goal is to reduce 50% by 2050. So we understand that GC, we could not really achieve this by ourselves, our own. So as a corporate, we understand the necessary to work with startups, innovators, peer investors, government, customers, pretty much everyone else in the energy and chemical supply chain. So as a venture team, so we are at the front line interacting with this most dynamic group. And that is why, together with DPAS Showcase, so we're honored to be able to bring some of the best experts and the best startups that we see in the space and to the event today. And we hope that through this small event, everyone can generate some new ideas and some new thoughts and bring back home some new takeaways so that as a community, we grow together. And that could be one small step towards our common decarbonization goals. So with that, thank you very much for your attention. So please feel free to reach out to any of us if anything that I mentioned resonates with you. So Lisa, please take the floor from here.
All right. So first, we want to thank Deep Tech Showcase for letting us partner on this Decarb Showcase. We're super excited about our panel discussion and the companies that you'll see pitch. And as you all know, decarbonizing the chemical sector, it's hard. Developing technology can take a really long time, and funding can be a real challenge. So today, we will try to demystify that funding for the decarbonization of chemicals. And we've got a great panel discussion to do just that. So we've got Kim Zhou, CEO and co-founder of Sightline Climate. We've got Neil Dykman, who's a partner at Energy Transition Ventures, or ETV. Kristen Marshall is research director at Lux Research, and Carol Radke, she's a technology to market advisor at the Department of Energy's SBIR STTR programs office. I'm going to let each of them introduce themselves. I couldn't do them justice. And then maybe they can talk a little bit about their background and their position in the ecosystem, and then we will launch into questions. So Kim, let's start with Kim. Kim?
Awesome. Hi, I'm Kim, CEO and co-founder of Sightline Climate, also the creators of the CTVC newsletter. My quick background, started the CTVC newsletter 4 years ago to broadly track what was happening in climate tech, especially as the clean tech, climate tech wave started to re-emerge, and then was an investor at Energy Impact Partners, which is a large, I think, 3 billion AUM venture firm, and helped build out the deep decarbonization fund called Frontier there. Now we've been working on Sightline Climate for the last 2 years. We're building a market intelligence platform focused on climate tech. So helping investors, corporates, governments, financial institutions navigate what is a very evolving climate transition, climate tech landscape. And we do that through providing more dedicated data and research on the space.
Fantastic. Thanks, Kim. Neil, do you want to go next?
Absolutely. Thanks, Lisa. I really appreciate you guys having me on. So I've been doing this for a long time. I'm doing venture capital these days. I've been in y'all's shoes. I've been a founder 6, 7, 8 times. Yeah, some of them very successful, some of them miserably not so successful. Yeah, so I have held every executive job in a startup very badly. Yeah, 1 or 2 of them okay, but most of them badly. And so now I'm a parasite. I'm on the venture capital side. My sole goal in life is find founders, give checks to founders, and cajole them and help them try and make me fabulously wealthy, and hopefully them even more fabulously wealthy. Yeah, we've been doing clean tech for my whole career. ETV is a new brand. This portfolio got set up about 2 years ago. We launched in 2021. Yeah, but I was at a firm called Jane Capital back in the day, was one of the early big writers in clean tech. I was Clean Tech Blog and was behind cleantech.org, and then spent a short stint at Shell for a few years there helping launch what was now Shell Ventures, or Stevie Fund 2, now called Shell Ventures. And then about 2 years ago, hooked up with my partner and launched this firm. And we are back to the races. So doing a lot more hard tech and deep tech than we had imagined, because the world's changed, and things that were frankly not very attractive to invest in 15 years ago, like electrolyzers, are pretty exciting these days, given what's happened with the technology stacks and the economics in the field. So really excited to meet you guys and hear the rest of the pitches later today.
Great. Thanks, Neil. Kristen, how about next?
Yeah, absolutely. Hi, everybody. My name is Kristen Marshall. I'm an associate research director with Lux Research. We are an emerging tech research and advisory firm. So we work with various Fortune 500 companies, in oil and gas, and also with large brands, as well as government institutions and investment firms, on helping them to identify interesting emerging technologies to solve some of the world's biggest problems around climate change, as well as their transition towards more circular economy. So I help to lead our chemicals service, meaning I focus specifically on materials related innovations, and I talk to various innovators, in different innovation areas, whether it's plastic waste or advanced plastic recycling, all the way to things like bio-based materials and chemicals. And yeah, I'm really excited to be here today. My background's in chemical engineering. I have a technical background, and so excited to be here and to hear the pitches as well.
Thanks, Kristen. And Carol, last but not least.
Okay, thank you. So I'm really excited to be here today as well. And I think if I could distinguish myself from everyone on the panel, except for Kim, I think we're a little bit different from the rest of them. I am here representing the Office of SBIR and STTR programs at DOE. And we, unlike the VC side of things, we have non-dilutive funding. So our funding is not going to take any pieces of your company. We're not going to ask you to pay it back. We're not going to take your IP. So that's the benefit that I can bring you by talking about the programs that are available within our programs office. I joined DOE in July of 2021 as a tech to market advisor. I was the first tech to market advisor they had hired in this particular program office, and I'm solely responsible for partnering, which is another important piece of the development cycle, because we do have non-dilutive funding, but it's not going to go all the way into taking you from concept development to the market. So you are going to need partners, and you are going to need additional funding. I spent 20 years prior to this in the SBIR arena as a commercialization service provider. So in my years of doing that, I have worked with, personally worked with about 700 small businesses with SBIR funding, but engaged with thousands of them. And my background is physical analytical chemistry. So.
Great. Thanks, Carol. So let's get into the questions because Brian only gave us 20 minutes to do this. So let's get going. Neil and Carol, I want to start with the two of you since you both work for funding sources. So Neil, let's begin here. ETV is invested in some companies themselves that are decarbonizing chemicals. And how do you see the funding needs of companies that are trying to decarbonize chemicals or materials being different from other kinds of startups? You know, what specific challenges do they face compared to other kinds of startups?
Double the timeline, and in most cases, a lot more cash needed. Yeah, so we're running basically what I'd refer to as the Tom Baruch playbook. Tom ran CMEA Ventures many years ago. He's an LP in my fund and a longtime friend. And basically, it boils down to find the Carols of the world and make the government and customers pay for everything, because you can't do R&D in this sector on all equity. It doesn't work. It's the timelines don't match. The money's too expensive. So you got to build a capital stack, which is some non-dilutive customer money. Yeah, and then program money, sometimes a joint industry partnership, something, and then the equity can fund patents, overheads, sales, et cetera, but it can't fund R&D. Yeah, our simple rule in life is I want, for early stage in chemicals in this sector, I want 5-to-1 non-dilutive to dilutive funding in the early days. Yeah, that's how we build the capital stack. And you plan for basically an infinite burn. You got to be able to live off of grant and customer programs while the equity can support your acceleration and growth prospects. You can't flip that script. And almost every investor who does has ended up needing to exit early, drive a heck of a lot of value, and then sees the companies struggle. If you're going to build a sustainable company, you got to lean over to the customer a lot more than you would if you were sitting in a consumer or other types of businesses.
And do you think the customers know that?
Some of them, the good ones, the stupid ones you don't want to talk to anyway. If a customer doesn't give you money, they are not a customer. They are an innovation ecosystem hanger-oner. So ignore them and go focus on the customers that actually partner with you as a startup.
Okay, great. And Carol, going back to you, I know that the DOE, primarily is focused on energy, but given the electrification of things, including processes that make chemicals, it seems like the agency's provided funding to startups in the chemical space, which might be a surprise to some who may not think to look there for funding. So within DOE, how are solicitations determined?
Right. So first, I just want to say that there are 13 different program offices that participate in the SBIR and STTR programs office that I am part of. And so the topics, although they align with the DOE mission, they're much broader than most people expect. So I would really encourage people to go and look at the topics, because we have cybersecurity topics, we have a lot of advanced materials, a lot of electrification. So just keep that in mind, that the program office I am within has 13 different program offices we support that supply topics to us, but there's also ARPA-E. They have their own SBIR program, and also the Office of Clean Energy Demonstration is standing up a SBIR program that will have their own topics. So how do we come up with our topics? The 13 program offices that we support, we would go out to them. We do 2 releases, I should say that first. So we do a release in July, that is our basic sciences release. And then we also do a release that just came out last week, and I'm going to put the link in the chat when we're done here. And that is our applied topics. And so I think that those of you that are sitting in this particular session should look at those topics to see what is out there. But at any rate, we ask those program offices, what are the things that you're interested in seeing funded? They know that one of the statutes of the SBIR and STTR programs is that the technology has to be commercializable. So in that respect, we do solicit vendors to provide market research to them on different topics of interest, and then they can review those as they're putting together their topics. And some of those are publicly available, so I'm also going to put the link for that in the chat so that you all can go ahead and take a look at them. But the process takes quite a while, for them to figure out their topics, and then put them into a document, has to go through legal, all of that. But then they get released. And we did just release topics that includes EERE, which is has quite a bit of topics in it. So you'll want to take a look at that document.
Okay, great. And Kim or Kristen, I don't know if you had anything to add on how funding decarbonization in chemicals is different than other sectors.
Yeah, happy to add a few thoughts here. So at Sightline Climate, we closely track funding, especially funding for early stage companies in the climate tech space. I think particularly in industrial decarbonization and chemicals, it's historically been an area we found to be underfunded relative to other verticals like energy, transportation, even carbon, which seem to, in many ways, be call it more consumer facing, right? You can drive a car, you can you pay your energy bills, even things like carbon. There's a bit more of a tangible kind of understanding of the need to remove carbon removal. So because for a while industrial decarbonization and especially chemicals and refining have been somewhat further up the value chain, up the supply chain, so we don't particularly pay attention to it. That's been one of the reasons we've seen that sort of call it misalignment between decarbonization impact, climate impact, and amount of funding going into the space. So we have a couple of charts that show that difference between verticals. However, what I will note is that over the last year or so, there's been a pretty significant uptick in industrial funding. And this isn't specific to chemicals, but we are seeing pretty massive rounds such as, H2 Green Steel over the last few months raising $1 billion on top of the couple of billion they've already raised to finance and build a massive green steel plant in Sweden. And I think all of this is, to Neil's point, building or industrial decarbonization is very capital intensive, especially if you're trying to build a new plant or implement a new technology. It requires a lot of capital, both from venture and growth investors, but down the line from commercial banks, from infra investors, to really bring that capital stack all together. And it's not to say that it's not possible. I think, as we noted, we're starting to see these rounds coming together where there's almost a blending of these different capital stacks. So, for example, in the H2 Green Steel case, it was venture / private equity investors like Just Climate coming in addition to European sources of grant and their version of the Loan Programs Office, sort of, which is the European Investment Bank. So you're seeing those capital rounds coming together to finance these larger industrial plants or projects, but it's obviously fewer and far between. The other trend I'll note on chemicals and industrial decarbonization, there are a lot more. There's that kind of there's a spectrum. There's one side of the spectrum that's building these large, massive plants, and then there's more kind of, call it asset light or retrofittable solutions. So we're also seeing things like membrane separation or synthetic biology approaches that are a bit more capex asset light, and so are approaching it in slightly different business models. So rather than trying to build and raise a ton of capital to build a new greenfield sort of project, looking at business models like licensing or working closely with the corporate or potential future buyer to retrofit a solution. So a bit of a wider range, but definitely seeing, I think, the interest shift from what was once mostly energy and transportation to looking at some of these harder to abate sectors.
Excellent. Kristen, I have a question for you. Given the breadth of the startups that you must see at Lux, are you seeing any trends, maybe on the good side, like government funding, or troubling trends like maybe investor hesitation, that are related to these decarb startups' ability to raise funding? And are any sectors gaining more traction than others?
Yeah, that's a great question. And we are starting to see more support on the government side. I think that's a important that's an important need, right? Especially I think in terms of like the bio-based space. And we talked about the consumer, there is a consumer element here as well, just because consumers and the willingness to pay more for some of these chemicals and materials that are being produced through alternative routes has been a big question mark, right? Even if you put the funds in to scale something up, there may be a premium, right? Still be a premium. And so are there going to be government policies and regulations put in place to try and even the playing field? I think that's interesting. And I know with things like the IRA and the, Biden's $2 billion executive order, coming out to help not only scale up technologies in the space, but also, especially with the IRA, trying to implement some costs, some fees to potentially even the playing field. However, I'd say for the most part, these types of funding opportunities are more incentives based, and so I've heard from startups that they've had a little bit of a difficult time in terms of this securing the funding there, just because of how it's typically been trickled down. So there is government incentives at play, and we expect to see more. But I think that the startup space in general, just the economic climate in general, has been challenging to secure funding, especially in the chemical space, where, as Neil mentioned before, long timelines, right? Long times to wait for return on investment. And we even have seen companies that have gone public, Origin Materials, Danimer Scientific, right? Those stock prices have seen a significant drop in recent months. And I think also there's just this, not wanting to wait, right? And also, in addition to that, I would say that the important thing here is making sure you are setting realistic expectations and timelines with investors, and meeting those timelines, because I think in some of these instances that we're seeing, that's not happening. So while the situation is a bit mixed with government support coming out, but investor hesitation and more taking a more serious look at the companies that they're investing in, right? Not getting lost in the hype. There are some technology areas. I know Kimberly mentioned some that we're seeing interest in. I would say there's a lot of interest in nearer term opportunities with regards to things like retrofitting or making use of existing infrastructure. So we're seeing, especially in the chemical space, the use of things like bio-naphtha to offset fossil naphtha in production. We're also seeing interest in things like drop-in bioplastics, where versus novel bioplastics, because there is this need to develop a market, right, when new materials are involved. And so really there's this priority on thinking about the timelines for adoption of things, especially when it comes to decarbonization, because we need to meet 2040, 2050 goals. That being said, there are some longer term prospects. Kimberly mentioned before, uptick in interest in things like electrolysis. Chemical companies are thinking about the future. And if we are to take part in this energy transition, there's going to be a need for different sources of carbon, hydrogen. Where are we going to get those from? With regards to carbon, there's going to be recycling, there's going to be bio-based resources being used, but also potentially using CO2 to produce chemicals. And then there's also opportunities in new materials development as well. But I would say not only from a direct decarbonization perspective, but with regards to indirectly supporting the energy transition. So for example, new materials development around, building up hydrogen infrastructure, right? So what are those pipes going to be made of? So there's opportunities there also. I know that was a long kind of, there's a lot of thoughts, right? There's a lot of things to potentially address.
Well, look, Lisa, let's talk about what's changed in the last 15 years. Right. So there was a time 2 decades ago when no venture capitalists would touch a company that had government money in it. That flipped after the Bush hydrogen acts, and all of a sudden venture capitalists started selling, oh, I'm the guy that can go get you into DC and get you free money. That obviously settled down, and we're in a much more nuanced world these days. But that was, 20 years ago, this was not a thing. 15 years ago, it became a thing. Today, it is part of the core capital stack to go build one of these companies. The other thing that's changed, in 15, 20 years ago, when we were working on all these clean tech technologies, everything needed a green premium because we called it alternative energy because it was more expensive than conventional. Today, solar and wind are cheaper than gas. So the world's flipped. So now all of a sudden stuff, regardless of a price of carbon, there's some fundamental interesting economic shifts that we can now take advantage of. I think, yeah, Kristen, I think you're right. There is a future for an electrochemical or a non-fossil based feedstock chemicals world, which means, okay, let's go do something with feedstocks like CO2 or water. As one of my scientists used to tell me, if you're going to do anything interesting with CO2, you better get a free available hydrogen from somewhere. So all these pathways got to go find that. So I think we're in a rewrite of an electrochemical future based on dirt, cheap electrons that is changing a lot of super interesting stuff on top of the decarbonization pushes that are those two threads are now coming together. And it's not that venture capitalists won't fund the sector. They will. It's that if you're a founder and you take too much money or have too high a burn for a plan that's going to take you 10 years and you think it'll take you 3, you will lose your shirt even if the VC makes money. So you got to run the business a bit differently. But today we have upside and a blue sky future to run to in this sector that we just did not have 20 years ago.
Yeah,
excellent point. I do want to get back to Carol because I know that we've only got 4 more minutes left and we could talk about this for hours.
Yeah.
So maybe we should do this again sometime. So Carol, I just wanted to come back to you about the SBI or STTR side. We all sort of think of these programs as early stage or seed funding, but how far can a company really get with that funding? We probably all know about getting a phase 1 or a phase 2, but are there opportunities for DOE beyond those 2 phases? Maybe you could talk a little bit about that.
Right. So just as all of you all have just mentioned how difficult it is to move a technology, from the feasibility stage, which would be phase 1, then building out a prototype or starting down that road in phase 2, DOE does recognize that. And so we offer in the SBIR and STTR programs office sequential phase 2s. So theoretically, you could have up to 8 years of funding. And so the sequential phase 2s give you the same amount of money you would get with any of your phase 2s. So you can really add that on to each other. So you could have a phase 2A or a phase 2B, and then there is a phase 2C. So you can't have 3 additional, but you can have 2 additional. And a phase 2B just means that you took a gap year.
These 2 huge grants going on.
No.
I mean, it's pretty crazy.
Anyway, I think someone is not muted, but so you can move much further down the development path.
Well, no, you freaked out like 2 years ago when we started all this, and you're like, okay, you got a 2-year head start on him. That's why it's like, God, what?
I don't know how to mute anybody. But I will just say that there is a lot of additional funding and more than people often think. And also the Office of Clean Energy Demonstration is out there now, which is a new office that was set up. And even though you need to come in with a commercial partner to be able to access those funds for the large scale demonstrations, there are some smaller programs for small businesses. They have a voucher program. And so that I think it enables between 50,000 and 250,000 of additional funds to just do test and certification, to do engineering design work. So there are some other opportunities for funding out there.
Excellent. Brian, do we have time for one more, or are you going to cut me off?
Oh, we could do one more if it's quick.
Okay. Neil, I just wanted to ask you a quick question about the capital that's available for startups. We talked a little bit about this, but for chemical decarbonization, is it underfunded? What are your thoughts there? And if it is, where are the key gaps in terms of where do we need more money, at the beginning, the middle, the end?
At the risk of annoying people, look, a founder today is sitting in the middle of the biggest pile of cash on the planet. The government is shoveling so much cash into this sector that the inflation for tech R&D is just, it's orders of magnitude bigger than what I could ever imagine when I started in this business. There's more venture capitalists than God running around. I can't even keep track of them. Maybe Kim, maybe you can. I can't even remember the list anymore, or even where to find the list of the lists. It is a really rich environment to find cash. Does that mean it's easy? Well, no, raising money is always hard. And you have to be a lot more careful these days to put your capital stack together in a way that is conducive to the next, the next phase of what capital you need, because the first money you draw will limit and change what the next money you draw can be, is, how much, what price, etc. And so you kind of got to, as a founder, you have a much more rich environment. This is not underfunded. If anything, it is well overfunded. But that doesn't mean it's easy, and it's definitely messy. Yeah, so I think you should just relax and go sell money. I mean, Carol just listed like 3 more things that I didn't know about. I've already sent her 2 of my little startups. Go find Carol, get Carol to explain to you where to go bid these things. Yeah, and so I think we're in a good spot, but that doesn't mean it's an easy spot for a founder to navigate, right? Just this little conversation today is telling you it's not easy to navigate.
Right. Excellent. Well, at the risk of annoying Brian even further, I guess we will wrap it up. Thank you very much to our panelists. You were fantastic. A lot of the panelists have put some notes in the chat, so please have a look there, follow up on some of those resources. Thank you again. Thank you, Brian, and I'll hand it back to you for the pitches.
All right, and thank you so much, everybody, for that wonderful discussion. It was really riveting to hear. And with that, what we'll do is we'll enter the pitching portion of the event. Just because we're slightly over time, what I'll do is we'll have the companies pitch. Each company will pitch for 5 minutes. They'll share their screen. Once the company stops pitching, the panelists will who want to ask questions will raise their hand on Zoom virtually, and then we'll call on you and you could ask questions. And what we normally do in an event when we have a bit more time is we have the panelists introduce themselves before the pitches start, but just to save on time, what we'll do is at this point have the panelists introduce themselves as they ask questions to the companies. So whenever a panelist who during a session never asked a question before asks a question, just say, hey, I'm XYZ and I do ABC, and then proceed to ask your question. And with that, we will move on to our presentation. So first we have A2O Advanced Materials, and we have Damon, who will be representing them. Sure.
Okay, so I'll just jump right in. I'm presuming everyone can see my screen properly.
Yep.
Excellent. So yeah, thanks again to all the panelists and everyone for coming. My name is Damon Gilmore. I'm VP Research at A2O Advanced Materials, and I'm excited to share with you today about how our technology is transforming adhesion. A2O Advanced Materials is a materials innovation company. We're headquartered in Vancouver, Canada, and our mission is to transform how people think and use bonding materials. And our goal is to eliminate product failure, increase performance, and eliminate waste in high-impact industries. So across all sectors, products rely on bonds to maintain their top performance and function. And yet, in today's day where decarbonization is an intense focus, it's really imperative that we get better bonding materials in order to enable these goals. At A2O, we're deliberate about choosing applications that not only increase performance and reduce costs, but our goal is that all of our applications have a transformative impact on sustainability. So to really enable this new bonding era of sustainability, we need materials that retain their performance for longer, so work better, safer, longer. Of course, conventional coating materials right now inevitably fail. This results in excess cost and waste. And yet, despite this, we still rely on adhesive chemistries that were first developed over a half-century ago. The fundamental transformation that A2O is introducing is overcoming is that within conventional systems like epoxy, polyurethane, conventional bonding systems, they only form bonds during the curing step. In contrast, A2O is developing amino polyolefins that harness dynamic bonds that constantly change with their environment. Our materials are enhanced in wet and under and water conditions. They're highly flexible, so they could accommodate mechanical stress. But the really key difference is, if you think about a conventional curing system, it can't reform bonds once the asset's been deployed. So if any of these failure mechanisms occur, the asset fails. In contrast, with our system, since they use dynamic bonds, the material's constantly reforming bonds. So it's actually constantly regenerating adhesion. And this enables the material to be reused and also enables recycling opportunities. So how some of these dynamic properties manifest in the bulk material. Our materials have an incredibly wide scope of adhesion. They stick from anything from metals to composites to low energy materials like plastics and fluoropolymers. Our materials are autonomously self-healing, meaning when they're cut, damaged, or scratched, they harness these dynamic bonds to autonomously refuse and restore their tensile strength. And these bonds are reversible, meaning you could stick and restick. And what this really means is these bonds are constantly regenerating. So you could forcibly delaminate a substrate, bring it back together, and it will heal. These materials are also waterproof and stick well underwater as well. Our core technology is a breakthrough process to form these amino polyolefins. Notably, this material class is the way that these material classes are produced commercially, they're very expensive and only used for specialty applications. Our route overcomes this. We can aminate multiple material classes, and we formulate these materials into coatings, adhesives, as well as additives within other formulations. Our short-term entry market is providing our unique library of diverse amine additives to enable higher performing partner formulations. Our first segments of focus here are within amine hardeners to improve epoxy formulations, as well as rubber additives to improve processing performance and circularity once rubbers reach the end of their lifetime. Our massive growth opportunity is within the anti-corrosion field. So we're developing a self-healing primer coating that prevents corrosion, and notably, it has superior underwater performance. And if the coating is damaged, it could self-heal to regenerate its barrier properties and prevent accelerated failure like conventional coatings. And our first target segments here are oil and gas and the marine industry, where coating failure is, results in significant economic and environmental penalties. Our go-to-market plan is we're currently in the midst of strategic relationships to provide the additives within partner formulations. In parallel, we're piloting our coating as an anti-corrosion coating within marine and oil and gas. We're using progressive pilot demonstrations to reach larger customers with the goal to ultimately partner with a larger multinational to expand into the global market and de-risk for larger adopters. We have a robust patent portfolio spanning from the core technology to composition matter to applied fields of use, and the technology and improvements have been exclusively licensed from University of British Columbia, from which the technology originated. We have a passionate and dedicated team focused on bringing this to market, and we're currently in the midst of a seed financing round where our goals are to scale up manufacture to pilot reaction, prepare our materials for commercialization through certification and regulation, and continue to expand the team and our development capacity. So thanks a lot for your attention, and I would look forward to any of your questions.
All right, great. That was great. Thank you so much, Damon. So with that, we'll open the floor to questions. So whoever has a question, just raise your hand. So we have Tom, and Tom, before you ask, just introduce yourself briefly.
Did I close my screen, Brian, or?
You could keep this on if you'd like.
Sure.
Well, so I'm Tom Blum. I'm an active angel investor. So have funded 50 or 60 companies so far, typically as an angel, but some of my investments are considerably larger. I'm in the New York Angels and Clean Energy Venture Group and a few other groups. So I represent one class of money that you companies are presenting to. And I'll say with advanced materials, you demonstrated the challenge we have. I know so little about your actual business. So the question I have is where are you in the rollout process? Have you do you have lead customers who have been testing your materials and would give you a commercial order, or are you still working to get that?
Yeah, I would say that's the stage that we're currently, like, that's the next inflection point that we're really on right now. So we currently, in our efforts to put our additives into other formulations, we have a number of relationships that we're involved in right now, material transfers, so on third-party evaluations. And then for our own formulation, we're in the midst of doing pilot demonstrations in the marine and oil and gas space. So we're still kind of pre-commercialization, but we're anticipating, like, our goal is to unlock our first sales within 2 years, because we've got a technology readiness now where we can scale up to 2 kilos, we can provide compounds for evaluation, and we're ready to continue to scale. And that's part of what we're raising funds for.
Cassandra?
Yes, thank you for a great presentation. I'm Cassandra Carruthers, early stage, deep and frontier tech investor across climate, health, and other critical technologies. My question is specific to your early entry or beachhead applications of marine and oil and gas that you mentioned. What are the primary materials in use today that you're competing against? Are they things like hexavalent chromium or super alloys? And how will your pricing initially compare to those other materials in use?
Right. So our product for the anti-corrosion, it's a organic coating. So this isn't like a metal deposited coating. So we're competing directly against polyurethanes, epoxies, fusion bonded epoxy. What we've already demonstrated is these materials rapidly fail under moisture and underwater environments. So we've already shown differentiation there. We've got really exciting lab data showing that you can if you damage FBE, fusion bonded epoxy, it is, totally unable to recover its corrosion barrier, and accelerated failure occurs. With ours, we're able to recover the property. So we've shown some very powerful, in our minds, differentiation, showing how using a dynamic system versus the curing system can give you some really powerful benefits. And I guess I could also comment that we've also demonstrated through our the pilot demonstrations, we've had underwater specimens immersed for over 3.5 years in the ocean with no loss in performance and no evidence of corrosion.
Thank you.
Oh,
Great.
sorry. And to the point on cost, we are still a little bit more expensive, like these materials are commodities, but we are, within striking range. And our process, one of the benefits of our process is we can form our materials cheaper using our catalytic route. So right now, we're more expensive, but not like several orders or at anything. And that's only at the scale of 2 kilos. So we have the opportunity to not only reduce cost, but also have a huge performance delta. But we need scaling to continue to do that.
Awesome. Up next, we have Julia.
Hi, thanks. I'm Julia. I'm a general partner with Convergent Ventures, a San Francisco-based seed stage fund investing in health and sustainability. It's really interesting. Thanks for the presentation, Damon. I'm just curious if you're making any enemies in the supply chain. And just for the backstory, we've invested in a self-healing paint company before, and there was tremendous interest from the end customers, but then it was hard to play along with the existing technology and providers of your end customers. And so, because they're not in the business of selling less adhesive, less paint, et cetera, unfortunately. And so I'm just wondering if you're seeing this, how you plan to partner with, the supply chain or disrupt it.
Yeah, that's a great point, Julia. And I would say that we have encountered that a little bit. And that's partially why what we've kind of learned through all of our customer interactions is that having someone adopt your own formulation is too big of a jump. So to de-risk the technology, that's why we're specifically working within partner formulations. We've already shown how our additives can improve the properties of those materials. But what we see is the transformative system is the formulation we're developing. So that's why we're using investment to continue to develop our own formulation so we can bring it to our short-term market. And at that point, once we demonstrate with end users, that's when we hope to overcome that kind of technology adoption lag that there could be, because we'll have a product that's at kind of like TRL 9 ready to go.
Sounds good. Thank you.
Thanks for your question.
All right, great. We have Takeo.
Hello, thank you for the presentation. I'm Takeo Ikeda from DIC Corporation, a Japanese chemical company. I'm manager of CBC. My question is that you already maybe talked, but what is the best application for your adhesives, and what is the challenge to applicable the area? And the last question is the adhesive can be applied for the food packaging area too. You can make a FDA or something. That's the question.
Okay, yeah, sure. So the reason why we've targeted these applications is because the needs are so enormous. These are applications where we know these coatings are failing, right? And they're failing fast and rapidly. And both of these industries face really difficult cost balances between the cost of the coatings versus the cost of maintenance. And as maintenance has gone up and energy costs have gone up, customers in these sectors are now opting for more premium products because it makes more long-term sense for them to do so. The critical feature that we are overcoming here is underwater performance, the breadth of adhesion that we can stick to so we could tie different layers together, and then the self-healing to regenerate the coating ability. Within packaging, we've looked at that a little bit, but that hasn't been one of our lead primary areas of focus at this point. But we do recognize that since our materials stick such a broad scope of materials together, their ability to function as tie layers between dissimilar materials is certainly of interest and a good application for us as well.
Understand. Thank you very much.
Thanks for your question.
All right, and to wrap it up with our questions, we have Keith.
Hi, Damon. So I'm also here in Vancouver, and I'm chairman of Foresight. First question is, are you taking advantages of Foresight services? Are you working with those programs?
Yeah, so we've engaged with Foresight. I think we've gone through a few of the pitches, but we've done a few events with Foresight. So I would say we're generally quite familiar, but I would maybe love to connect with you offline, Keith, and maybe explore, because it would be a great time for us.
Great. So now I'm not going to be able to go as deep on chemistry as Ikeda-san can. He and I know each other from my previous role. Before that, I was president of BASF Venture Capital, and in the last fund I had Henkel as an LP. So I know adhesives in the space quite well. And I've seen a lot of venture-backed companies in this space struggle with very long commercial adoption timelines. And how are you prepared to deal with, looking historically, decade-long path of adoption for these types of new materials?
Yeah, so it is, that's certainly a major challenge for people in our field. And I think that's partially why there's been such a lag of innovation in the adhesive sector. I think the time is right for new adhesive innovation. And our company is specifically trying to accelerate technology adoption by being very collaborative and forming partnerships at an early stage. We're not trying to deeply understand every industry. We want to find the right partner in the industries that we want to play in and focus on them for development. It is a long road, but I think we have a plan for kind of breaking what can be kind of a decade-long cycle.
Well, I wish you lots of success with that. I can certainly see the advantages of your materials.
Thanks. I really appreciate that, Keith.
All right, great. So with that, thank you so much, Damon, for your presentation and fielding questions. Feel free to leave your contact info in the chat as well. So if anybody wants to get in touch with you and doesn't remember or didn't get a chance to get down your contact info, they could reach out. And with that, we'll move on to our next presentation, which is Kepra, if I'm pronouncing it correctly. And we have Julie here to present.
Right. Hi, everyone. My name is Julie Krang, and I'm founder and CEO of Kepra. We're a chemical technologies company working on next-generation fertilizers. Farmers lose half of all of the fertilizers they apply. It goes up in the atmosphere, it runs off into rivers, and this is a $5 billion loss of material every single year. It's also an $89 billion mitigation issue. We have a solution to this that is kind of a holistic approach. It's a novel fertilizer blend that sequesters carbon in the soil, reduces runoff, and cuts costs for farmers because they can use less fertilizer. This can be a greater than 10% cost reduction for farmers. It's also a 55 to 100 over 100% reduction in the carbon intensity of fertilizer, depending on the blend. And it helps farmers maintain their yields and their profit margins by increasing the amount of nutrient uptake by crops. And in customers that we've spoken to, including big names like American Crystal Sugar and ADM, this is a silver bullet. They want to use less fertilizer while not increasing their costs or reducing their yields. And it's even better if they can increase their yields. How we do it is we synthesize carbon negative synthetic humic acids from waste biomass. What they do is they act like a sponge in the soil. They hold applied minerals and nutrients and water in the field, as well as stimulating the plants to uptake more nitrate. It sequesters carbon in the field when it's applied, while also increasing yields up to 30%, and it is an independent source of nitrogen. It sounds a lot like biochar, but it's not biochar. It's higher performance than biochar, particularly because biochar has no inherent yield benefits, and it's a drop-in solution. So what we do is we take this material and we replace some of the synthetic fertilizer in the blends, as well as the fillers in those blends, which are also a carbon intensive material. We have very strong economics at scale. So a typical fertilizer blend goes for about $575 per ton, and we can sell a blend for $527 per ton. We also have the opportunity to increase our top line revenue through carbon credits. Even though standalone, it does work economically. We generate 1.4 tons of CO2 equivalent sequestered per ton of material we make. Farmers can generate carbon credits as well by reducing the amount of nitrate and NOx gas emissions from their fields from fertilizer. And at scale, our facilities have a projected IRR of 31% for the low price of $5.6 million. It's all enabled by a novel reactor technology based on high intensity focused ultrasound. This is a fully electrified chemical reactor that uses sound to drive chemical reactions. It's capable of producing immense temperatures and pressures, which we've applied to a whole host of different chemical processes, including hydrodeoxygenation and cracking plastics into fuels. But the silver bullet here is that it reduces the reaction time, the residence time in the reactor. The easy way of understanding that is it makes chemicals faster, and that allows us to make chemicals cheaper and cost competitive with petroleum-derived chemicals. And this technology platform is more energy efficient than combustion technologies. It's commercializable at even smaller scales than most combustion reactors, and it has a whole broad range of applications. To date, we've optimized this technology at the benchtop scale and scaled it up to a demo unit, as well as we've designed a small-scale commercial pilot plant, and we have identified pilot sites and secured feedstock partners, as well as government partners in order to establish that site. 2024, we'll be building that plant and conducting field trials for our materials. 2025, we're expanding to full-scale sites across multiple sites and investigating the other additional markets that this technology could potentially be applied to. We have a massive opportunity at this time for carbon abatement and top-line carbon revenue. And our final stage will be to transition to a turnkey licensing model for these facilities that can be easily adapted and applied to different markets in the chemicals industry. I'm a biochemist from UC San Diego. I did research at NASA Ames Research Facility in biomaterials. My CTO is an electrical engineer, former founder of a company called BrainGrid, and 15 years power electronics engineering experience. And my CFO is a serial CFO for a whole bunch of different startup companies, including Starfire, a green ammonia company. We have 4 university partners, as well as we've been backed by some great VC funds. But most importantly, we've built deep ties to the kind of local people that we need to have on our side to establish our facilities, including feedstock partners, field trial partners, an Ag Genomics Research Institute, and government sources of funding. We planted sorghum seeds using our material, and our plants in the early growth grew 2 to 3 times larger. So now we're planting a bigger seed. It's now $4 million. It's a bit more expensive, but it will cover 18 months of runway, pilot commercialization, expanding our team, and conducting those field trials. Thank you.
All right, awesome. So with that, we'll enter the question portion, and we have our first question from Alexander.
Hi, everyone. Alex Roosevelt here, Climate Impact Capital here in Houston. We provide a bridge between climate tech investors and large corporations through a hybrid fund. And my question is around how you plan to scale up your reactor. You kind of talk about a small reactor, but the acoustic energy and the flows as you go up, change technically quite a bit, and we've had experience, in this before. And so that seems to be a very large risk, especially going into the ammonia space where you're typically your competitor are large plants that are making hundreds of tons a day, if not an hour. So please tell us a little bit about how you're going to manage that technology changeover from where you are to where you need to be.
Yeah. So our current reactor is a 1,200 liter reactor. We've done complex acoustic modeling and fluid dynamics modeling. To scale into the synthetic humic acids, we're basically operating reactors in parallel rather than scaling them up volumetrically. We have done the early work to go up to a 12,000 liter reactor, which would be more suitable for commodity chemicals. But there's definitely a lot more development there that needs to take place. So economically, operating in parallel does work for the market that we're in this beachhead, particularly because these technologies need to be kind of distributed in order to suit the feedstock as opposed to, try and move the feedstock to the facilities. And this also is kind of the ideal scale to work with local fertilizer formulators, which do tend to also operate at smaller scales. So the way I see it, this is kind of a backdoor to fertilizer decarbonization, where you don't actually have to completely replace the $100 billion Haber-Bosch plants and compete with them on price.
All right, great. So we'll move on to our next question, which is Tom.
Yes, thanks. Here's your chance to try to explain to a layman what is actually happening. How do the pressure waves from your ultrasound cause something to happen that therefore results in less energy otherwise being needed?
Yeah. Ultrasound drives chemical reactions in a few different ways. One of the best understood ways is it increases the sort of surface area of reaction and mixes it up better due to these kind of little waves that move things around in the reactor. So if you have a catalyst, or if our reaction is actually alkaline, it just makes it move at a faster rate that way. It also generates heat through essentially frictive heating, and the pressure waves creates compression and pressure within the reactor. And then the fourth way is that it generates cavitation. So these little bubbles form, and then they expand and they implode violently, which releases a shock wave of energy. It's kind of the icing on the cake. It helps increase the efficiency of the reactor.
All right, great. And we'll finish it up with Dan.
Hi, I'm Dan. I'm with BDF Ventures, but I'm also a scout with Alumni Ventures. I loved your presentation, especially your silver bullets. My one quick question is there a kind of plant where we cannot use this, some kind of seeds maybe where you cannot use these technologies, or it is applicable to any plant, any kind of seeds out there?
It is applicable to any kind of seed out there. The differences in the form factor, the final form factor of the product would be the blend of nutrients. So, corn uses something different than cotton, but that's something that's easily modified with the fertilizer formulator at the kind of end stage of the supply chain.
Okay, great. So that seems to be about it for questions. But Julie, please leave your contact info in the chat so people can reach out to you if they want. And we'll move on to our next presentation, which is Carbix.
Thanks. Let me know if everyone can see the screen.
Yeah, I can see it.
Cool. Hi, I'm Quincy Sammy. I'm the founder and CEO at Carbix, and we're capturing CO2 emissions from point sources and transforming them into advanced materials for the global building and construction industry sector. The problem that we're addressing is carbon capture and utilization from industrial sites and natural gas plants. The current suite of technologies in this emerging industry are still evolving, but they're often complex, inefficient, and represent a huge cost burden for hard-to-abate industries. Our technology avoids these issues. We capture CO2 and generate product on site. Our technology is a photobioreactor that's designed to fast batch CO2 into carbonates within minutes and seconds, unlike nature, which can take 1,000 years. Our reactor performs these critical functions through a combination of high and low speed mixing, heating, variable CO2 partial pressure, UVC dosing of water inputs, and finally energy recovery with thermoelectric generators. There are, I think, two main items that separate Carbix from startups and incumbents. First is our ability to uptake up nearly 50% or more per batch into a carbonate product, and also generate multiple revenue streams from those carbonate products. And when our technology is fully deployed at scale and processed as well, we can eliminate up to 80% of industrial as well as natural gas plants, power plants, point source emissions. The market opportunity is $1 trillion global construction and materials market. Our focus is cement and concrete. We like cement and concrete because of the volume. It's the second most widely used material in the world. The only thing that we consume more is water, and because of that volume, it represents a durable sink for CO2 emissions. Over the last year and a half, we've been fortunate to work with companies like Saint-Gobain, where we're actually planning our first pilot. And recently, we've started product certification for our carbonate cement and concrete blends with a grant from NYSERDA and Columbia University. We conducted a study of one of Saint-Gobain's plant in Europe. It's a float glass facility. And this is an example of the multiple revenue streams that we can generate from just CO2 emissions. The key takeaway from the study was that we can operate with expenses below 50 per ton and generate margins close to 40%. And we're capturing a total of about 90,000 metric tons of CO2 and displacing as well about 250,000 metric tons of CO2 from the use of our carbonate cement products. So this is an example of our product range. So we produce cement powders, which can be used for aggregates, and separately we can produce high purity carbonates for use in food, pharma, plastics, paints, and coatings. Our cement aggregates are cement powders as well because it's got a low carbon footprint and carbon negative, reduces GWP by about 80% compared to conventional Portland cement. We can offer our cement blends in a ready mix package, as well as engineered stone and also high purity separately. And in instances where we are carbon negative and we have a lower CO2 input, we're also eligible for credits in the EU, the ETS scheme, as well as the 45Q domestically. And this is our team that's responsible for our past and future success. Myself, over 12 years in clean tech design and engineering, and I lead our team on all fronts, supported by our CSO, Vinit D, who's a PhD in aerodynamics, and works on CFD solvers, as well as reactor flow studies. And we're supported by 2 great advisors, both PhDs in their respective fields. Over the last year and a half, we've recently started our product testing and certification to ASTM and industry standards. And that's recently and ongoing. And previously, prior to that, we completed our X1 MVP reactor design, which has been running successfully for the last year and a half. And now we're looking forward to our scale-up pilot in Northern Massachusetts. The way that cement and concrete are made today is simply not sustainable. And we really believe that the gold standard for future cement and concrete products will involve carbon capture and use, as well as our technology. So that's why we ask you to join us as a partner in this opportunity of creating a carbon negative and carbon neutral future. Thank you.
Right, great. So we'll open up the floor to questions. Julia?
Hi, thank you for your presentation. Just wondering, because I'm not a chemist, if you end up changing the chemistry or the formulation of the concrete and the cement, and if so, do you see this as a barrier to adoption? Because even if it's a very large and very important industry, it's quite a conservative one.
Actually, no. And part of the testing that we're doing with ASTM standards is to that fact. So there's a range of testing that we do, and concretes have lots of different blends and lots of different admixtures. Our primary carbonate is calcium carbonate. That alone is like 60% of cement products. But not just concrete, we're also getting mortars tested as well, lime-based mortars, as well as a mafic blend of cement. So the category that we'll probably get certified under is supplemental cementitious materials. And then we can also produce a synthetic OPC, but that's a bit of a longer development curve. And so our go-to-market is really going to be SCMs and aggregates as well as high purity carbonates.
Thank you.
All right, Alexander?
Yeah, and just to follow up on that question on the testing, where did you get on your compressive strength? The cements that we're looking at, in this market are 30,000 to 50,000 psi. And so are you kind of hitting those targets with your mixes? And then the other one was around, and I think you may have answered is where in the process you're coming in. So as SCMs, you're mixing into the cement, you're not adding anything to the batch concrete process. If you can clarify that.
Sure. Could you just repeat the first question again?
The first question is the compressive PSI strength targets that you've hit so far.
Gotcha. So in-house lab, we've hit about what's called an M30 design strength mix, which is around 3,500 PSI. I think roughly 30,000 pounds. So our design mixes are going to be anywhere from M1, which is decorative, all the way up to about an M50, or M70, which can be used in bridges, structures, heavy load cases. So the specific blend, I can't get into details because some of that is proprietary. But in terms of changing the actual concrete product, no, we're not going to be doing that. Although our blends can replace OPC completely, industry standards pretty much forbid that. So at this point, what we're doing is, as a SCM, we can get replacements up to about 40 to 70%, depending on the type of cement product that's application for anyway. So, with compression tests starting around 3,500 psi, we'll be working our way up to 70, 80,000.
Thank you.
Right, and Takeo?
Hi, Takeo Ikeda from the DIC Corporation, Japanese chemical company. My question is could you tell me your value proposition again? Is that the miniaturization of the system is your value proposition, or the reducing cost and adding the decarbonic side?
So I think sure, our value proposition is that we can reduce cost to the point source, as well as generate a product, so that we're not a cost sink or a burden for hard to abate industries, because CapEx could be quite huge. So instead of being just an expense on their CFO's balance sheet, we're also going to appear on the revenue side as well. So that's why it's important to convert CO2, utilize it, and then generate sales to offset installation. And so that, I think, in a nutshell, is our value prop.
Okay, thank you very much. And in the building material area, also, as you said, cost is also important. But if you could add the value, maybe your revenue get better. So are there any possibility by using your technology, the concrete become like better characteristic for some durability or something?
Right, compared to, and it's a little challenging because we understand going into product testing that we may not be able to 100% replace Portland. But in the tests that we've done so far, our compression strengths are higher than Portland cement because of the mix of carbonate and mafic blends that we use. It's also better in terms of corrosion because it's mostly carbonate. There's less chance of carbonation corrosion or carbonation-induced corrosion long term. And also in terms of water permeability, some of the admixtures that we do use will help reduce water permeability, chloride attack. So the value prop is CO2 emissions, stronger concrete that's less corrosive.
Thank you very much.
Okay, great. Tom?
Yes. So the challenge I have as an angel investor is you just made a very convincing presentation.
Thank you.
But I'm also an investor in carbon upcycling, and I'm willing to spread bets across the board because there's no way I could due diligence my way to understanding who's going to be the winner. But there's going to be a whole bunch of winners in this organization of concrete. So I'm curious if you have a investment structure that is favorable to angels being able to come in, crowdfunding or other method, or do I have to be a VC and go through a whole detailed due diligence before writing a check? Because by the time I'm afraid your valuation may be too high.
Yeah, it really depends on as you know what your thesis is as an angel and what your what your risk threshold is. Just a disclaimer, we are a portco for Prithvi Ventures, and they're also an investor in carbon upcycling. Small world. So there's a lot of interest in the cement and concrete space. I'd be open to talk to you directly offline to see if we can work together.
Well, that works for me. I'm not sure about everybody else on the call looking for investment opportunities, but yeah,
happy to chat.
And but you can imagine how hard it is for a non-expert to make sense of this. My view is I'll just make a whole bunch of bets because even if you gave me a lot of time, I don't think I'm smart enough to figure out who's going to win. But
the cement space is huge. So I mean, if you look at the incumbents now, they're top 10 cement manufacturers control basically all the production, and all the production is coming out of Asia. So I think as startups grow, it'll probably become as fragmented as it is now with incumbents, and then go through M&A consolidation at some point. But that's, I think, way down the future.
All right, great. And we'll wrap up the questions with Paul.
Hi, Quincy. I'm Paul Garcia from the Air Force Office of Energy Assurance. I'm a senior advisor for business development. I had a quick materials question for you. If you can tell us, what is your mineral source for your carbonate?
So our mineral resources are a wide variety. So there's not one. We have actually almost a dozen, which are primarily calcium silicates, calcium sulfates, and any type of waste material, like lime kiln dust or cement kiln dust, mine tailing, stone dust. So we've been, as part of our testing and certification, we've been surveying different sites, building a database, and then composition of the materials, whether they be freshly mined or recycled minerals. So we do use a wide range of minerals, not all of which I can disclose at this time. But as we go through product testing and cert with the labs that we're working with, we'll ultimately have to disclose everything at some point.
Thank you.
All right, great. So that's all we have for Carbix, but please feel more than free to leave your contact info in the chat so people could reach out after the event should they want to connect. And we'll move on to our next presenting company, which is Turnover Labs.
Hey everyone, I'm Marissa Beatty. I'm the founder and CEO of Turnover Lab. It's great to be here. We're a CO2 utilization company that's using electrolysis to upgrade waste CO2 from industry into valuable products. So the topic du jour is, of course, about decarbonizing industry. The chemicals industry is a notoriously hard to abate sector, due in no small part to the fact that these are pretty large projects, pretty CapEx intensive projects that have long lifetimes, make it pretty difficult to swap out equipment very easily. So a lot of attention in this particular sector has been focusing on add-on solutions like carbon capture, which can also be kind of difficult within chemical manufacturing due to the fact that a lot of emissions are dilute. So there's a lot of energy requirement associated with carbon capture. But not just that, a lot of point sources coming out of chemicals industries have impurities in them, and not just any impurities that can be directly deactivating to a lot of carbon capture technologies and cause them to age a lot faster than in other applications. What this means is carbon capture has to look a little bit different in the chemicals industry. You have to install upstream impurity removal steps in order to get these impurities out before it undergoes this carbon capture step. That can be quite intensive from a cost perspective. And then at the end of it, what do you have? You have CO2, which is a pretty low market material, pretty low cost. Doesn't really have a lot of use cases or applicability within industry, so it typically has to go out elsewhere. That's a lot of logistical complexity, depending on who you are. So the way that folks have been looking around this is, okay, let's turn CO2 into something that's more valuable, something that has a higher selling price. Maybe we can make some money from it. Unfortunately, a lot of conversion technologies also require pretty high purity CO2. So you have to go through all of this initial waste cleanup, carbon capture, and then you put it into the conversion reactor, and these conversion reactors are also notoriously unstable. They age really fast. They start drifting in what products they make. And because of that, you basically get this carbon soup mixture out the back that requires some pretty intensive separations upgrading, which can really add on cost on top. So a lot of folks that are doing CO2 utilization are kind of confined to selling high value products for niche applications, or are having to put things in these giant centralized facilities, and they're shipping CO2 and products all over the place. So it's getting pretty complex. And this is no more represented than in electrolysis. Electrolysis is becoming a darling child of industry, particularly because it's used for green hydrogen production, scaling up quite quickly. There's a lot of people coming into the space to develop hydrogen electrolysis infrastructure. And that's because it's pretty great. I think it was mentioned earlier, electrolysis can gobble up those dirt cheap electrons from the grid. So it pairs great with renewables, but it's also continuous and it's immediately responsive, which everybody in the chemicals industry really enjoys. Startup shutdown times are very annoying for a lot of different processes. But CO2 electrolysis faces the same problems as hydrogen electrolysis in a lot of ways. One, it's crazy expensive, or more expensive than hydrogen electrolysis in a lot of ways. Has a short lifetime. They break down insanely fast. And again, they're plagued by that same carbon soup problem on the previous slide. So you're already taking an extraordinarily expensive technology, and then you're having to slap on additional capital cost just to keep that interior electrolyzer alive because of the sensitivity problems, how quickly it ages, and how sensitive they are in general to impurities and becoming deactivated over time. So at Turnover Labs, we're trying to build the next generation of ultra-durable electrolyzers for CO2 electrolysis. We do this by addressing issues with durability and selectivity within the electrolyzer itself. So we've been working for about 6-7 years at Columbia University to build electrodes that repel impurities away from the surface, things like oxygen, SOx, NOx, other deactivating impurities, while still being receptive to uptaking CO2 and upgrading them into carbon products. And then we get two essential streams, one full of waste and one full of the products that we need that are not intermixed with one another. We've also been working on slowing down the aging of electrolysis systems so that we can squeeze more lifetime out of them. And we can prevent that issue of product drift that I mentioned, where we don't start making random other things that need to be separated out on the back end. What that translates to is we can remove a lot of the support infrastructure that's currently needed for electrolyzer technologies, and that makes our CapEx smaller, our OpEx smaller, and our process footprint a lot smaller. And that lets us navigate into making a different class of carbon-based materials or carbon products that a lot of other electrolysis companies, I think no other electrolysis companies are targeting explicitly, which is commodities like syngas, which is this mixture, chemical building block for a lot of different processes, ethanol, methanol, but also some different types of high waxes and also commodities. So there's a lot of applicability in the syngas market, but it's also very, very cheap, which is why it's difficult to produce electrochemically. So I'll walk you through kind of how this would look in a typical plant. Depending on your size, depending on what you're making, you will either bring in natural gas, syngas, or coal. You'll upgrade that internally into syngas, and then you'll emit some flue gas. Because we're small, we're cheap, and we're easy to install on the back end, we can bring in our electrolysis system to recycle that flue gas on site. So you don't have to compress CO2, transport it all over Kingdom Come, and then buy your products. Also with that logistics price factored in. Again, syngas itself, pretty cheap, one of the cheapest materials known. But that ratio of carbon monoxide to hydrogen, there are different price points within the syngas marketplace. And one area where it's very difficult and expensive to produce petrochemically is carbon monoxide rich syngas, which is our beachhead market. You can see it's quite expensive, and other CCU or carbon capture utilization technologies are coming in close. But when we look at our process and we model out our economics, we can actually come in at a slight price reduction. And that's even before we take in any carbon credits, and that's using a very rigorous 5 cent a kilowatt hour energy price. So we're not doing anything weird where we only run for 45 minutes in the middle of a desert. We're a pretty small team right now. Like I said, we spun out of Columbia University after working on this for a good amount of time, but I'm leading the project. This is what all of my work has been on the last 8 years. We have leading experts in the field of ultra cheap electrolysis that are on board. And we're moving right now from this small laboratory size into something that we can actually demonstrate at a pilot demonstration in the next year. So if you want to know any more, just feel free to reach out. We have a lot of existing support and awards from a lot of heavy hitting programs, but we're always excited to learn more. Thanks.
All right, thank you so much, Marissa, and we will open up the floor to questions. So if anybody has a question, just raise your hand and ask away. Oh, Tom.
Yes. Do you have a TRL number that you would say we're at this stage? And are you looking for outside investment at this point, or are you still working off of grants?
Yeah, so we're definitely looking for outside investment at this stage. We have the support from some VCs as well as some non-dilutive funding as well. I know it's a dirty number to say at an industry comp or an industry talk, but we are at TRL 3. We're looking to upgrade to 4 in the next year, though. That's primarily due to the fact that there's a lot of infrastructure already in place for hydrogen electrolysis, and we can kind of tack our technology on top of it. So our scale up profile can be a little bit faster than like niche technologies in the field.
Great. And Alexander?
So I was much more excited at the beginning of the presentation than towards the end, and I'll kind of tell you why, and I'd like to kind of delve into that. So you talked about this issue of selectivity through which at the end of the electrochemical process, as you said, you get the soup of chemicals, and we've looked at electrochemistry across a number of potential investments. And given your kind of claim that you have this really great approach to selectivity, why are you targeting the carbon monoxide kind of markets, given that they are not the kind of end goal of where we really need to decarbonize the energy systems? I have a hard time kind of believing that we're going to be building out a big syngas market in the future versus trying to find more direct routes to ethylene and propylene and ethanol using that same approach that you talked about before. So can you kind of maybe parse that as to is that a long-term plan that you're gaining towards, or is it why you're out this way, and can you take your technology in the end to really get to clean sources of ethanol and methanol and other secondary precursors beyond CO?
Sure, yeah, and we can chat more offline because I have a very long and robust answer about where I think electrochemistry should be focusing their energy on. One thing that we're targeting with carbon monoxide and syngas specifically is we can actually directly tune the ratio of hydrogen to CO in syngas, so we can target some initial applications that are pretty difficult to achieve petrochemically. There's also a lot of installed infrastructure already on the ground that's upgrading carbon monoxide and hydrogen into larger chemicals. The initial transformation step from CO2 to CO is pretty low energy intensive, and the catalysts around electrochemistry for CO2 into CO are very vetted. They have high selectivity. They're a lot further along than things that are trying to make carbon-carbon bonds, at least right now. That being said, a big issue with the catalysts that are trying to make carbon-carbon bonds and more complex molecules electrochemically, one of their biggest issues is stability, and we are compatible with multiple catalysts in the field. We would definitely look at that later on, but there's still just a big issue about the energy intensity and about how much work we really want the electrolyzer to be doing, rather than being supplemental to infrastructure that we already have installed that can start deploying pretty immediately and start using syngas to make these chemicals.
And just a little quick follow on before you answer the next question. Does that mean that your selectivity stage is integrated into the catalyst stage, or can it be done separately so it can be a bolt-on to any process that has the carbon-to-carbon bonds?
Yeah, so we can go across multiple different catalysts. We are catalyst agnostic right now. We've explored with some that are capable of making carbon-carbon bonds. We worked a lot in the hydrogen space with platinum catalysts as well as fuel cell catalysts. So we are completely independent for the electrocatalyst of choice. We basically build a scaffold system that protects catalysts from degradation and deactivation. So we're not limited or confined by that. We're within the electrolyzer doing that separation at the electrode surface.
Thank you.
Okay, awesome. And we'll have the last question come from Cassandra.
Yes, thank you, Marissa. It's a quick question, and forgive me if I'm making you repeat yourself. Just wondering on the economic side, you mentioned towards the beginning that, you know, part of the status quo is extremely expensive, extremely, like all of these problems. Can you quantify your comparison with some of those existing status quos, please?
Yeah. So a big thing is that we can undercut depending on the composition of what people are making electrochemically. We basically don't have to pay the materials or the upgrading cost for CO2 cleaning or compression or capture. So depending on where you're getting that CO2 from, that can be between $60 and $120 added on to your process cost. So that's something that we can avoid because we can take dilute contaminated CO2 directly. So that's one area where we eliminate process cost, as well as CapEx from installing the carbon capture system and the impurity removal upstream. Now on the downstream, particularly for the syngas that we're targeting, there are a lot of different upgrading steps as well. Some of them are things that are really nasty to install and very expensive, things like cryogenic separation of CO and hydrogen. Because we're able to sort of turn down the amount of hydrogen that we evolve, we can avoid having to install that capital as well. And that's a pretty expensive piece of equipment. So that's where we sort of reduce on our costs on the overall process, not just the electrolyzer. And then finally, because the breakdown of our electrolyzer is a lot slower, we get a longer lifetime for the same amount of installed CapEx. So that's how we pare down cost also.
Okay, great. Thank you so much, Marissa. And if you wish, just put your contact info in the chat so people can reach out should they want to connect or ask you any further questions. And with that, we will move on to our final presentation for the first session, which is DexMat.
Thanks, Brian with a Y, from another Brian with a Y. Great, I'm Brian Guido-Hassan, CEO of DexMat, which is a decarbonization moonshot, displacing hard-to-abate industries worth trillions of dollars, responsible for gigatons of CO2 emissions with advanced carbon-negative materials. We care about materials because making stuff is a huge contributor to climate change, right? These three materials alone, steel, aluminum, and copper, contributing nearly 10% of all human emissions, and they're becoming more challenging, right? As we kind of electrify everything, we're running out of a lot of the easy copper, running out of a lot of the easy minerals that we use to make aluminum. And attempts to address these challenges thus far have been pretty unimaginative, mostly taking the same materials and trying to make them kind of slightly greener. But DexMat is really going back to first principles and reimagining a future unconstrained by these dirty, centuries-old materials. So based on patented IP from Nobel Prize-winning scientists at Rice University, DexMat produces Galborn, an advanced nanomaterial made of pure carbon. It is stronger than steel, lighter than aluminum, it's conductive, it's flexible, it's biocompatible, corrosion resistant, carbon negative, infinitely recyclable. It's basically better in every way, except cost right now, because we're producing it at such a small scale, but we'll get to that. So the applications for Galvorn are essentially as broad as your imagination, ranging from next generation power transmission lines to lightweight conductive cabling for automotive, maritime, and aviation applications, lightweight cut resistant protective gear for ranging from sports to industry to military applications, electrothermal de-icing for everything from wind turbine blades to aircraft wings, cathodes for ultra high powered devices, even wearable electronics like EKG sensors. Essentially, the vast majority of things that the dirty incumbent materials can do, Galvorn can do, and in many cases can do a lot better, and in all cases can do a lot cleaner. So DexMat actually began life as a spin out from a DoD grant several years ago, and it's built on more than $20 million of non-dilutive funding. A lot of that was spent improving the properties of the material, co-developing applications with customers, but a lot of it also went to scaling up production capacity and reducing cost at such a kind of frenetic rate that we have to plot it on logarithmic plots, as you see here. But DexMat's story is not one of toiling away in a vacuum to reach commercial scale and only then checking to see if there's a market for this. We have to move with purpose and speed due to the nature of the climate and the energy transition challenge. So we're simultaneously validating markets at the same time that we're scaling up on the supply side. We have a lot of focus right now on near-term commercializable markets. So for us, this means consumer electronics, wearables and e-textiles, even sporting goods. These are markets that have low volume requirements, high price tolerance, and crucially, rapid product development cycles. But at the same time, we continue to develop options in much larger markets in aerospace, defense, and automotive. For markets that will require interaction with the public sector, like power line transmission, there we use a grant strategy to make sure that we're kind of engaging with the right parties. And we actually just won a new $1.2 million grant from the Department of Energy for next generation power transmission lines. And we're having a lot of early success. We got early traction across all of those markets. And this is a bit of a logo soup slide, but these are all paying customers, many of them multiple time customers with increasing order volumes. And across this wide kind of swath of pretty diverse application spaces, they basically all tell us the same thing. The material's amazing, but if you really want us to build a product on it, you need to be able to produce much more of it, and it needs to cost a lot less. So DexMat is scaling up and reducing cost rapidly so we can begin displacing the dirty incumbent materials across all of these markets at massive scale. And that could mean having 2 to 3 gigatons of annualized CO2 impact. We took the first major step in this scale-up journey earlier this year. We closed a small seed round, $3 million led by Shell Ventures, participation from Aramco Ventures, Overture Ventures, Collab Fund. So we've got plenty of runway. We're not actively raising right now, but we've basically hit all our milestones for the round. We scaled up this year production capacity by more than 20x. We've reduced unit cost by 90%. We built out a lot of the team, especially the non-technical team. And so we're starting to have conversations now to lay the foundation for a Series A raise that we'll do in the first quarter of next year. This isn't software. This is going to be a capital intense path to commercial scale, but in less than 5 years, we believe we can hit cost parity with the high end of steel and with carbon fiber. And that's a crucial inflection point for us at which we no longer will have to compete based on value or green premium. We can basically just begin displacing those materials at massive scale by being a better new standard. It's a great team for this early stage of a scale up. Professor Matteo Pasquale, the world leader in this kind of advanced nano material production, several of his former PhDs and other engineers who have the experience to scale up this type of manufacturing process. And increasingly members of sales, marketing, finance, operations to build a more complete and robust team as well. So I'd welcome questions and discussion about how DexMat is ironically using carbon to decarbonize the hardest to abate sectors, not by making them green, but by making them obsolete.
All right, great. Thanks, Brian. So we'll open the floor to questions, and we already have one from Julia.
Hi, Brian. Thank you for your presentation. I'm sure you've gotten this question about a gazillion times, but how, you know, how can you ensure that you're not going to have the same pathway as graphene of a lot of excitement about the material, but difficulty scaling up, and especially difficulty for end customers to prototype with and, you know, find real life applications?
Yeah, it's a great question, one that we think about a lot today, and certainly have thought a lot about basically since the beginning of the company. And to be clear, it's a spin out from Rice University, which has several graphene spin outs as well. We consider you know, friends and fellow travelers. But you know, one of the challenges for graphene has been that it's a very novel form factor, and so prototyping around it has been challenging. We're producing, so, and I didn't dive into this, but we produce Galvorn in several form factors that map to existing industrial standards. So our most basic form factor is a fiber. So you can think of it as like carbon fiber, Kevlar, fiberglass, a number of industrial fibers that are out there. We can then build more macroscopic constructions. We can twist the fibers into yarns. We can braid them into braids that are, you know, similar to, you know, copper braids, for example. We can produce it as a tape or a film, which is great for wrapping applications like EMI shielding. And then for both the fibers and the tapes, we can weave them into fine meshes that can be constructed soft and supple as a fabric, or stiff as the basis for three-dimensional composite materials. So part of the advantage here is that our materials drop into existing supply chains. We're able to use existing off-the-shelf manufacturing equipment and machinery as well. So there's a lot less friction to market adoption. The challenge for us is one less of, hey, can we get, you know, people to prototype with it and what have you. It's more of kind of selectivity and focus on key markets that are accessible to us early, rather than ones that'll, you know, drag on for years before we have anything kind of really significant to point to.
Okay, that's great to hear. Thank you.
Cheers.
All right, great. Up next, we have Alexander.
Hey, Alex.
Brian, good to see you. Yeah, I visited the lab some few years back, so glad to see things are moving along. Can you give us some more kind of perspective, you know, about, you know, which of these, you know, dirty existing products that you're trying to decarbonize? Because in my view has always been these types of products kind of move into the market because they have better capabilities around either conduction or strength or everything else. And they're very lightweight, so there's a really key fit for it. But I've never really seen a good kind of explanation as to why they're going to be like the key to decarbonization. So maybe what are the, you know, 2-3 top markets that you think, you know, at volume that this will, you know, create significant, you know, thousands of tons of decarbonization?
Yeah, and so a great way to think of it, Alex, is really in phases and in steps, right? So today we're producing at a very small scale and a very high cost, and so we're in very kind of niche applications. So let's take commercial aviation as a specific sector to zoom in on. So today, companies buy our product to use for electrothermal de-icing, essentially sew our fiber into the wings of an aircraft, run a current through it, it melts the ice, it's faster, it's less expensive, and certainly more environmentally friendly than bombarding aircraft with chemicals. But we're never gonna have gigatons of CO2 impact with, you know, a little bit of kind of thread in each wing. But as we scale up and reduce cost, then it becomes palatable for us to displace the single-digit tons of electrical cabling throughout an aircraft. So there's both powertrain cabling and there's sensor kind of data cabling as well. And in most commercial aircraft, it's tons. In very large aircraft, it might be, you know, more than 10 tons. That starts to become very significant. We have a much more significant share of the materials used in that aircraft. As we really scale up and reduce cost, then our objective would be to displace structural materials. So already the fuselage, the wing are produced from carbon fiber, Kevlar, fiberglass, et cetera, which are great. They're strong, they're lightweight, but they're not conductive. So they have to blend in a lot of copper, which is incredibly heavy. It's another single digit, or in some cases, double digit number of tons in order to protect against lightning strikes. Whereas our material is already conductive, and so it obviates the need for that additional copper. So over the course of kind of our scale up and cost reduction, we can go from taking a tiny fraction of the material share of an aircraft to actually a very significant volume of it, obviously increase our share of the bill of goods as well, all while dealing with the same customer. And the same kind of three phases map to automotive as well, where today we're doing kind of Litz wire for wireless charging. But as we scale up and reduce costs, we can take the hundreds of kilograms of conductive cabling in a car, even in an ICE vehicle, and reduce it to tens of kilograms, and then ultimately take the structural components as well. So the vision, Alex, that we ultimately, the sustainable future is built on Galvorn, not just electrically conductively, but in structural ways as well.
Yeah, so to kind of summarize it, it is really a better material, lighter material play, which will then kind of obviate the scope 3 emissions by making the planes lighter, making the vehicles lighter. So it's tied to that, and it clearly has a lot of also applicability in defense and other areas that need lightweight and other materials. Okay, that's very clear. Thank you so much, Brian.
Cheers, Alex.
Okay, great. Thank you, Brian, for your pitch. We'll move on to our next session, but again, thank you so much, and feel free to put your contact info in the chat. And also thank you for spelling your name with a Y. Very much appreciated.
The only way to spell it. It's amazing that so many Brians misspell their own name. It's embarrassing.
Exactly. It's infuriating. Anyway, so thank you everybody. So that's it for the first session. We're going to move on to our second session. So thanks to the panelists. Thank you to all the panelists and companies who pitched. Thank you to all the companies who pitched in the first session. Thank you for all the panelists who joined us for the first session. Feel free to stick around for the second session if you'd like. And what we'll do is we'll just go into the company pitches like we did at the beginning of last session. Just because we're starting a new session, when you ask a question as a panelist, just introduce yourself briefly, just because the companies who are pitching in this session might not have been on when you introduce yourself earlier last session. So with that, we'll start our second session. And we have Alchemica pitching first.
Great. Hello. Thank you so much for taking the time to listen to my pitch. My name is Patrick Wagner, and I'm currently entrepreneur resident in a company called Ferment Co. And we launch new companies. It's a company creation studio that launches new companies which take advantage of synthetic biology and other in production of new and differentiated products and services. And I'm excited to talk to you about Alchemica, which is we are primarily a service and a solutions company which supplying products into the biotech and biogas industry. As you know, and I'm sure this is the news to anybody on this call, there is a more demand coming from customers and policymakers and industries to move to a lower carbon economy, and also to become more sustainable in our products generation. And with that, it's unsurprisingly we're going to require more alternative energy sources that's going to meet the energy demand for that energy transition. Biogas is actually one of the energy sources that is currently being utilized, that has been actually around for north of a century or so, and has been primarily produced in a process called anaerobic digestion, which basically takes mixtures of organic waste, be it sludge, agricultural waste, residues, food waste, manure, etc., and converts those materials into gas, and thus actually decreasing the overall volume that is required ultimately to landfill otherwise manage. So for that reason, AD has been historically used as a tool of waste management to really decrease the volumes and the costs associated with managing our waste. But over the last decade or so, there's been a lot of impetus kind of on the downstream element of AD, which is actually the production of the biogas. Now, why is biogas exciting? It's a roughly containing mixture of CO2 and methane. And it's an energetic mixture which can be used either directly in generators and existing boilers to make electricity and heat, or it can also be actually separated into individual components of CO2 and renewable methane, and that can actually be ultimately injected into our existing natural gas infrastructure. So for that reason, it's been a kind of a newly found resource, I think, and there's a lot of impetus on producing renewable natural gas to supplant some of the fossil-based energy elements, particularly natural gas. Now, what's happening, if you look at the market, it's a pretty established industry. Not surprisingly, from a supply perspective, it's primarily focused in Europe and North America, where the existing policy and regulatory environments are quite conducive to anaerobic digestion. But we're seeing more and more growth, and in sectors such as Asia and others, where the requirement for renewable energy is becoming more and more imminent. On the other side, on the demand curve, biogas is a very nice industry today. It's roughly estimated about a $50 billion market. And more importantly, it's projected to treble, nearly triple over the next 6 to 7 years. And for that, we at Alchemica believe that we're going to have to cross what we call as the capability gap. And that is really kind of go from the transition of a more of a artisanal kind of a waste management operations to more product-oriented biorefineries. And for that, AD operators will require new tools to allow them to actually more effectively convert carbon that is in our waste materials into biogas. And this is exactly where Alchemical comes in. Our product suite basically fundamentally enables the production of renewable energy by the utilization of kind of a triumvirate approach, whereby we provide digital, analytical, and biological products and solutions to our customers, who can then use those products to better understand the conditions of their process and the feedstock that they're ultimately converting. And we are also working with top-class biotechnology companies to develop biocatalysts, i.e. enzymes, which can effectively increase the ultimate flux of carbon into renewable natural gas. Now, from a commercial perspective, we have been quite active over the last 6 months, working very closely with big players in the biogas industry in Europe and also in North America, validating our business model, validating our approach and the products that we're trying to bring to market. And we've been very successful, and to our surprise and happy surprise, have been assured that our technology is highly needed, and we have been able to identify core strategic partners who want to be our first customer adopters and also help us experiment and ultimately optimize our products for commercial launch. Based on that, we've actually created revenue projections for our company, and on kind of conservative base case, we see ourselves as a company that will be north of a $300 million business. And if you're looking at the graph, we're projecting to start obviously a launch in Europe, where it's the biggest market at the moment, but continue to expand to North America and eventually into Asia as well. And with that, I think I'm kind of at the allotment of my 5 minutes, but I just wanted to kind of stress that we are currently raising a Series Seed round, and we're looking to raise $4 million, and that will give us the ability to complete the development of my products, but more importantly, test those in the field and with our innovation partners to optimize them and also underpin our overall commercialization and growth strategy. And with that, thank you so much for your time, and love to take any questions or comments you may have.
All right, thank you so much, Patrick. Opening the floor to questions. So if anybody has a question, just raise your hand on Zoom. We'll call on you and then introduce yourself before asking the question. Those people are taking the time to formulate the question in their minds. Yeah, Paul.
Oh, I don't want you to go with no questions. So I do have experience with biogas as the energy supply in Europe, particularly in Italy. One of the most common forms of renewable energy that they're working with. My question for you, when you talked about your partners in the technology, are you helping them beyond the software components that you're talking about in forming solution sets? Do you see that as an opportunity for Alchemica to sort of coach them on putting together end-to-end solutions. So the turnkey aspect of being a utility almost.
Yeah. No, that's a good question. So just to be clear, I think we're supplying 3 different product types. So it's both the software element, which is more of a digital tool that provides real-time information about the conditions of the reactors and also suggests recommendations, actionable recommendations how to improve efficiency. In addition to that, we're also providing analytical tools, which are effectively sensors that provide information about the reactor conditions, but also about the feed that is coming into the reactor, how it's changing and how it's going to likely affect the conditions in the reactor. And then fundamentally, the final piece, which is the big component, and that's the synthetic biology angle, is we're providing innovative novel enzymes, which help break down and pre-treat the biomass to a level where north of 20% additional biogas can be produced, just increasing the overall yield and throughput.
Thank you.
All right, Victoria.
Hey, Patrick, thank you so much for that. So I'm Victoria. I'm an investor with an early stage deep tech VC called Playground Global. Kind of curious, yeah, if you can sort of talk about on average, what are the yield increases that you can expect from incorporating this process? And then additionally, what does this enzyme development really look like? Is it particularly bespoke given a unique feedstock that you're kind of looking at? Or basically, like, are you going case by case here? Or is there something that you're kind of developing that's a little more feedstock agnostic?
Right, absolutely. No, that's a great question. So with existing enzymes products that we have tested, and we have partners in this space that we're happy to talk about offline, we can expect on average about a 20% increase in biogas yield with existing applications. Now, in many instances, these enzymes have not been optimized for the anaerobic digestion industry. And obviously the processes within the reactors and the conditions within it rather are very different from what you would expect in other industries where enzymes are ubiquitously used, such as ethanol, corn ethanol, cellulosic ethanol, et cetera. So we are actually embarking at the same time on launching a mission to identify new enzymes with another partner that we have in the biotech space, where we can identify microorganisms that are actually within the reactors that can produce particular enzymes for given feedstocks. And those enzymes we expect are going to be a lot more optimized for the process, and we expect another additional 20% increase based on those novel products.
Thank you.
Okay, great, thanks. So that's all we have for now for time. But thank you so much, Patrick, for your pitch, and feel free to put your contact info in the chat so people can reach out to you should they want to ask any questions or just follow up.
Great.
And with that, we will move on to our next presentation, which is more materials.
All right. Well, good afternoon, everyone, and greetings from Cleveland, Ohio, which is the venue for the AMI Global Plastics Expo, where I'll be spending the next couple of days. Many thanks to Deep Tech Showcase and GC Ventures for the invitation to be here. My name is Joe Pont, CEO of the Noir Materials, as well as the Warner Babcock Institute for Green Chemistry. And Noir Materials is the latest innovation to be spun out from Warner Babcock. So with that, okay, guys. All right. You guys see that? Wonderful. Yes. All right. So Noir Materials are at a very high level cost competitive alternatives to traditional thermoplastics and thermoplastic composites with, from my perspective, truly remarkable functional properties, in particular with respect to strength and toughness and processability. And Noir Materials can be designed to be fully compostable, home and ocean, or conversely, they could be designed to be optimized for circularity, for the circular economy. So diving into a little bit more detail here, Noir materials are derived from any base thermoplastic coupled with a filler, utilizing our proprietary universal compatibilization technology, using standard twin screw extrusion in what is effectively a reactive blend process. So taking one step further down there, the Noir material product that we're going to be selling are filaments and pellets, again, that derive from any base thermoplastic commodity, any filler, using our universal compatibilization technology to bring it all together in a reactive blend process, which is very much bio-inspired. Now, our filaments and pellets, we're going to sell B2B downstream across the full range of thermoplastic commercial opportunities, ranging from compostable commodities to high performance composites. And we are embracing a business model where we're going to be manufacturing these pellets and filaments in-house using standard twin screw extrusion. As we see, the CapEx is relatively light and a long lifetime for the equipment versus rather expensive toll manufacture. So our customers can take our Noir material pellets and filaments and using standard polymer processing technologies, take them on the products. Thin film extrusion to compostable ag films, trash liners, and the like. Injection molding, thermoforming for compostable packaging materials or for high performance parts. Textile manufacturing, rope fishing nets, parachutes, and additive manufacturing as well for highly functioning thermoplastic composites with super high loading of fillers, functional fillers in particular, like carbon and steel, which are enabled by our universal compatibilization technology. Excuse me. So just a quick summary of the key attributes of the technology of our Noir material. So produced from any base thermoplastic items of commerce, any filler brought together by our universal compatibilization technology and just standard twin screw extrusion equipment to deliver materials that perform fantastically from my vantage point, particularly in terms of strength, toughness, and processability. And we tick the sustainability box in two possible ways. These things can be designed to be compostable, or they can be designed to be optimized for circularity. And what I mean on that one is that our universal compatibilization technology can compatibilize mixed recycling streams. So we can go compostable, or we can go optimal circularity. Yeah, just to give you a quick snapshot of the Noir materials that we've reduced to practice. Just a quick snapshot here. We've made numerous Noir materials based on thermoplastics derived from biodegradables such as PLA, PCL, PBS, polyamides, nylon 6, nylon 6,6, and other non-biodegradables like polypropylene and thermoplastic polyurethane. And we've looked at the full range of fillers, organic to inorganic, waste to high function, to bring in either function or very simply to drive costs down, because one of our biggest cost drivers in this, particularly when we're going to be operating in commodity space for some of our applications, the big cost driver is going to be the base thermoplastic itself. So, so to highlight one key example to really show you the strength and toughness that really got us excited when we first discovered this technology. So this is our first generation. This is data showing our first generation Noir compostable film, which we compared side by side with Husky polyethylene-based trash liner and the Matter B BioBag trash liner, which is starch PBAT based. Both are on the market today. And simple message here: strength, toughness. We are a full order of magnitude stronger than the commercial products, either the biodegradable one or the non-biodegradable one. So we're compostable, and we're an order of magnitude stronger and tougher. On the IP side, we're in a pretty robust situation here. We filed our provisional a year ago, and that provisional was converted to a full patent in the PCT in Taiwan this past September. We took advantage of a accelerated examination grant due to the older age of one of our inventors, and we got an agreement for that they would do a quick examination. So we filed in the U.S. as well a few weeks later. So we've got a really good position here and strong IP, I believe. And as I've been saying, the raw materials have the ability to play substantially in what is really a huge, obviously huge, global thermoplastic market across commodities. We can compete in commodities as well as on the engineered thermoplastic side of things. For us, we're small. We're raising money, so we are focusing. And so we are focusing on a smaller portfolio of commodities and high performance composites, with emphasis on 3 base thermoplastics we're bringing in here. So PBS will give us access. The PBS noir material will give us access to compostable products going into horticultural packaging, ag films, and trash liners. PLA noir will give us access into durable compostables, industrial composites, and the polyamide composite, noir composites are gonna be our avenue into high performance parts. And we're really excited. We are a young company, and we are raising now what effectively is kind of a late seed stage. We're very excited that on the PBS side for horticultural packaging, we're currently organizing a 2,000 pound thermoforming trial to make a whole bunch of horticultural packaging in a commercial manufacturing facility with a potential customer, one of the largest horticultural packaging manufacturers in the United States. So we're very excited about that, as well as ongoing emerging customer relationships we're starting to build across the other base thermoplastics as well. So
Hey, Joe,
this is the
30-second warning.
Yeah. Oh, okay. Here's the Noir Materials team. I intend, I'll just deliver a quick message here. I'm hanging up my WB hat to be a full-time CEO of Noir Materials. Chris Livesey is the wizard behind all of this. Jim Babcock, Chris Hill from Cthulhu Ventures have been giving us guidance as well. They've been funding all of the work to date. We're requesting 3.5 million. That's what we're looking for. That's what we're raising. There's a good chunk of that is CapEx and personnel, and it's very key for us in terms of our ability to prototype, to validate with customers, and to build commercial agreements to move forward on the CapEx and personnel side. So there you go. That brings me to the end, and I'll hand it back to the MC here, and happy to answer any questions.
Sure. Thanks, Joe. So yeah, opening the floor to questions. So if anybody has a question, just raise your hand on Zoom and we'll call on you. John.
Hey, Joe, sorry if I missed this in the presentation. Did you say, is there a reason why the customers are incentivized to work with you in this product? Is it the green aspect? Is there like improved performance? What's the motivation there?
Well, it's both, frankly. What really brought, I mean, you can't just sell green at the end of the day. And we're coming from the Warner Babcock Institute for Green Chemistry, and we've known after many years of generating a lot of great science that performance and cost are first and foremost. And oh, by the way, very important, oh, by the way, you need to have a strong sustainability narrative built into the story. So, but what really excites people about all of this is the performance side of things. So people have the mandate to, depending on what market we're looking at here, to have the compostable product or have improved circularity. And we're talking to a number of the big guys out there who are producing polypropylene, as an example. They're just kind of, they're ticking time bomb, if you will. That they've been telling me, and they're just looking. They're desperate in many ways for improved circularity. But what really has giving us a strong foundation is the performance side of it. So, and that's kind of setting us apart from, particularly on the compostable side, sets us apart from technologies that are in the marketplace today.
Thank you.
Victoria.
Yeah, kind of curious, like if we're going down the circularity angle rather than compostable, what does that end of life really look like? And can it go into existing, recycling streams, or how are you envisioning doing this?
Yeah, that's a good question. So I will say up front here that, as you might have seen from the slide towards the end, in our focused portfolio, we're heavy on compostable / biodegradable and lighter on the non-biodegradable. So we are further behind technically. We are ready to do a lot of scale up work and validation at large scale on the compostable side. So we haven't done the studies to actually answer your question. I think that's the question that haunts anybody who's thinking about circularity. How do we, is there such a thing as a true circular thing, or is it all about diminishing the spiral? And so, I mean, the situation is what it is. The bottom line is that for the work that we've done with, for example, polypropylene, we've clearly demonstrated the ability to take mixed streams and to improve strength, toughness, and so you're basically improving the ability to bring it back into the circle. So that's not really giving you a firm answer there. I think that the technology is well suited to keep the spiral from getting too much spiraling downward and keeping it closer to the circle.
Thank you.
All right. Thank you so much, Joe. That's all the time we have for now, but feel free to put your contact info on the chat. Also, there's some questions that are in the chat, so just be cognizant of that and feel free to answer them there. And with that, we will move on to our next presenting company, which is Adept Materials.
Good afternoon, everybody. My name is Derek Stein. I hope you can see my screen. So I'm the founder and CEO of Adept Materials. We're developing climate regulating materials for buildings and other applications. To set the stage, here's a beautiful room, and I think the best design decision of the designers here was to put the plants in. So these two big plants are not only beautiful, but they're regulating the humidity, they're regulating the temperature, they're regulating their moisture content to prevent against mold and moisture damage, and they're even purifying the air. Now, by contrast, the building in which these things sit, like the other buildings that we're all sitting in, account for nearly 40% of primary energy use. It's more than a third of CO2 emissions traced back to buildings. And most of that is spent for keeping us comfortable and healthy. So what Adept is trying to do is take a tip from nature and create materials that passively regulate environments to save energy, improve health, and durability. So what we're commercializing is a platform technology. We have patent protection through 3 patent families on a 2-layer system that provides multiple functions to building envelopes and other applications. So these are things that regulate heat and moisture in useful ways. And I'll demonstrate what those ways are. So this demo will show our material embodied in a paint applied to the gypsum lids on these containers. Now, this demo is supposed to bring to mind a shower-like situation, one where the humidity loads are extreme. We put boiling water into these little beakers, and the hot, humid air is billowing out. And the lid of this box on the left has a conventional paint from Home Depot. And the conventional paint leads to the conventional result. Namely, you're getting condensation on the walls, and the humidity inside this box, if you read this meter, is rising up over 80%. In other words, these are the conditions that lead to mold growth and moisture damage in buildings. The other box is the same, except we have an Adept paint in the lid of this on this piece of drywall. You can see there's no condensation. because it's been able to sequester the excess away, and it's kept the humidity low. In other words, materials that you put in the envelope of a building can have the capacity to meaningfully prevent moisture from rising to dangerous levels inside. Now, the moisture that gets sequestered in these materials becomes available to store heat as well. The concept is pretty much the same as the one that we use to regulate our own temperature. So when you go out on a hot day and the sun is beating down on your head, we sweat a little bit, and as that sweat evaporates, it provides a cooling effect. In other words, water is changing phase, and that phase transition stores and releases latent heat. So to illustrate this, we painted our logo on a piece of gypsum panel, and we have our paint on top of a conventional one. And if I took a picture here with my cell phone camera, you don't see much of a contrast because it's just one white paint on the top of the other. They look the same. But in an infrared camera, the surface temperature, in this case, shows our logo about 5 degrees Fahrenheit cooler than the background. And that's because we had taken this from a cool, damp environment out into the sun, and this evaporative cooling effect was kicking into gear. We've collaborated with researchers from the National Renewable Energy Lab, and modeling this and integrating it into buildings, simulation showed that this will save between 5 and 10% of annual heating and cooling energy, depending on where it is and the style of building. Now, the last attribute of these two layers, the primer and the paint together, provide directional control over moisture. Water can escape from places it doesn't belong, like wall cavities. But then when conditions change and try to drive water vapor inside, potentially putting it at risk, this thing slams on the brakes and withstands that. It's kind of like a one-way valve or a diode for water vapor. To illustrate how this helps protect buildings against moisture damage, we've put at risk here the moisture-susceptible stuff on the planet, in other words, berries. And over 3 weeks, what you can see is that berries protected by our films, with the direction arranged to let excess vapor out, but prevent new stuff coming in, doesn't show any sign of mold growth on these berries. And the humidity in this box stays 15 percentage points lower than one protected by standard smart vapor retarders that are the leading edge in moisture control in buildings. And here, of course, you see that the mold has grown readily. Now, we're going to go to market with a primer and paint combination that regulates heat and humidity in buildings with a specific amount of value to preventing moisture damage. While everybody wants to reduce their heating bills, nothing motivates people like seeing mold that they need to get rid of in their bathrooms. And so we believe that these technologies have a lot to offer to the homeowner, also to property managers through preventing maintenance costs and improving on ESG scores. Just the bathroom market in North America alone is estimated to be $1 to $2 billion per year. So we're excited about this. This is a way of going direct to consumer with a product that will take us from 0 to 1 with a new technology. And we've also been excited to be working on other applications with other manufacturing and commercial partners for building products like films that will better protect buildings against moisture damage and reduce latent loads. Apparel, things that can replace the forever chemicals in Teflon while adding performance benefits. And packaging solutions that can prevent moisture damage for things like blueberries. The team is experienced. I have left my faculty job at Brown to pursue this startup company full-time. Our principal chemist has experience from Bell Labs to Saint-Gobain to Fujifilm. And we have building science experts like Terry Weston, who spent over 30 years at DuPont developing things like Tyvek. And to go direct to market with a paint product, we have the co-founder of Backdrop, a D2C paint company who's already built this kind of a business, even without the patent protection that we enjoy. We are raising a seed round to take our first products to market and to develop some of these follow-on opportunities. $4 million is our target raise, and this will go to the manufacturing and development of brand for the launch, as well as the further development of our IP portfolio for these new opportunities. And for that, of course, we will need some outward and inward-looking support and personnel. I thank you for your attention. I'm happy to take your questions.
All right, thank you so much, Derek. We will open the floor to questions, and we already have one from Lena.
Hey, Derek, this is Lena from Outsiders Fund. Thanks for the presentation. I'd love to understand better why you're choosing the go-to-market path you are of direct to consumer instead of going through contractors or through it looks like you are doing some with paint brands, but why not start there and do more of a B2B channel rather than sort of that direct to consumer?
The consumers we have found are extremely motivated to do things about the moisture problems in bathrooms. Direct to consumer is the channel where we have the quickest access to the end user who will see the benefits of this. So we can sell directly to those that care about it. We believe that doing that first will make it easier to pull through demand through other channels, like contractors. We've spoken, for example, to people who do affordable housing in New York, and there are huge problems with mold and so on in those kinds of buildings. And they would be the kind of contractors you're talking about. They want to know, has it been deployed in the field? And this is the way of getting it out there and getting people to write positive reviews on it.
Victoria.
Yeah. Hey, thank you. Can you speak a little bit about the material supply chain that you're talking about with this paint product? And then additionally, kind of curious about do you see any what do the degradation cycles look like here? How long is this going to last? How durable is it? Are you going to see any sort of deformation due to water ingress over time?
Okay, yeah, excellent questions. On the question of supply chain, maybe first an overarching point that I can make is that the technology is really based on physics rather than specific chemistry. So there's not one particular molecule that we have to embed in any use we want. It's really about how two layers come together and provide these useful properties. The inspiration part of it was plants. The other part was diodes, which you can make out of silicon, germanium, and even carbon materials. So in terms of the supply chain for the paints, let's say, what we want to do is use as much as possible existing suppliers and supply chains. So the binders that hold things together in our top coat, right? So like here's a sample of this stuff. If it stops blurring, it's Dow, BASF, Arkema, the same suppliers that make everybody else's stuff. One of the key ingredients in the top coat is a material that stores and releases moisture, right? We have a supplier for this application that is quoting us, in the tens to hundreds of tons mass. So it's readily available. The other layer is one for which the supply is even larger. There's no issue because this is already done at massive scale. With each application that we want to pursue, what we want to do is use as much as possible existing best practice in terms of the materials. What we want to do is just add these new physical characteristics that will create these useful moisture and heat management properties. Now, the last thing you asked about was the degradation. Materials that store and release moisture, I'll give you one example, bentonite. Bentonite is something with a huge capacity to do that, and you dig it out of the ground. And it's been sitting in the ground for millennia. So if it hasn't degraded under those circumstances, I think that the odds are good that it will stand another 10 years between paint jobs in a home.
Thank you.
All right, great. Thank you so much, Derek. That was a really great presentation. Please be sure to put your contact info in the chat so people could reach out if they'd like. And also, I believe that there's a question in the Q&A section. I believe it was aimed towards you. So if you want to answer that, feel free as well. And with that, we will move on to our next presentation, which is Recarbon.
Excuse me just one second. I'm just trying to make sure. I'm having a little bit of a trouble sharing my screen. Apologize. Here we go. Can you see my screen now?
No, I don't.
Excuse me.
If you'd like, I could share the screen for you.
Yeah, perhaps that would work. Sorry for that. Looked like I had some sort of a safety feature on that wasn't allowing me to do it.
No problem.
Let me just try one more time, if you don't mind.
Okay.
May
Sure.
solve.
All right, you got it.
All right, perfect. Thanks for that. Thanks for everyone's patience. I really appreciate it. Let me just go there. Okay. Again, thanks again for your patience. My name is Leo Kasehagen. I'm the investment director for Recarbon, and I'm very happy to share Recarbon's technology and business to make high value, high performance oils using feedstocks from agricultural waste. So when you look at decarbonization, one of the pathways that's obviously there is to move away from fossil fuels, natural gas, crude oil as a source for energy, but also as a source for materials. And this has some negative impacts, of course, unintended, but it does impact the cost of food. Even the availability of food contributes to deforestation. And worse yet, a lot of times the products that result are just simply inferior. So what Recarbon's idea behind Recarbon is to solve some of those issues. And what we do is to take non-food sources, biomass, typically things like corn cobs, corn stovers, the feedstocks that come from those, and convert those into high value, in this case, oils. Those oils have two target markets in our case. One of them is in emollients, moisturizers and personal care, and the other is in base oils for lubricants. Recarbon was founded by Dr. Vasudeb Saha in 2018, and he's assembled a team of people to advance the business that bring together deep expertise in the chemistry and the process. I'm not sure why that happened. The chemistry and the process technology, the specialty chemicals business, and importantly, the know-how around the applications in personal care and lubricants to make these businesses work. You'll see that we bring together a number of years of experience from a lot of the global manufacturers, global leaders that are positioned in different parts of the value chain to advance the business. If I can just give you a quick snapshot of Recarbon, where we stand. So of course, again, the value proposition is using agricultural waste, feedstocks from agricultural waste to make high performance oils. The technology, which I'll go into in a little bit, is proven up through the pilot scale. Up to 100 kg batches have been made and is protected by a portfolio of patents. There's a large market that we're going after between personal care and lubricants. I'll talk a little bit more about that, but it's a $9 billion market that can be addressed by the range of products that are produced out of this technology. Most importantly, we have good customer traction. Multiple customers have evaluated the products, given their feedback in the form of data up through license agreements and letters of intent to purchase. Based on all of this, we have a great deal of confidence in a business plan that would bring this to a $20 million per year EBITDA business by 2030. And that's why we're here today, we're ready to commercialize this, start producing it, and we're here to try to raise $10 million to accomplish that. Let me just talk a little bit about the Recarbon solution very briefly. Again, the idea is to take small molecules that typically come out of, when you produce from biomass type products, biorefineries, take those raw materials and in a two-stage process, first build a molecular weight with various coupling reactions, and then hydrogenate those products to clean them up into very pure branched alkanes. The products, the raw materials have well-established supply chains. They're available, ready to go. And the chemistry, the products, excuse me, the process is envisioned to be a continuous process, that's scalable and utilizes green chemistry. So no deconditions, no toxic chemicals, no solvents used, all of those things. I just wanted to touch briefly on the two target markets that we're going after. The first one being the emollients personal care market. Here we see a really immediate need for our product. There's some very strong drivers in the market. So first, consumers prefer natural products, green products. If you walk into Ulta or Sephora, you can see how everything is marketed that way these days. There's also some important regulatory pressure that's happening in the market. So some of the workhorses of this industry, particularly the silicones, have been and are continuing to be in a phased out situation led by European Union regulations. And the third thing I would say is that if you just look at the sustainability commitments of the various brand owners, you think about L'Oreal or P&G, there's all kinds of variations of it, whether they be sustainability or reducing carbon footprint, or in a lot of cases, just moving away from petroleum-based products altogether, usually by 2030. So as I said, the silicones and the white oils that have been in the industry, I've been there 30, 40, 50 years and are really, really good products in terms of performance. But there's a need to move away because of the sustainability profile. There's certainly things, the market's already moved in a lot of ways to plant oils, to various esters, but they have their downsides. Color, stability, things like that. They just simply don't perform as well to a formulator as the silicones and the white oils are in the market. The recarbon products perform like silicones, perform like white oils, but have a sustainability profile that's even better than plant oils since they're coming from non-food sources.
30-second warning.
Oh, okay. So the lubricant base oil is somewhat similar, but we're going after synthetic base oils, polyalpha olefins, where our product performs as good as that, but with a better sustainability profile. We have great customer traction. I'll just mention briefly that we have BASF has taken a license agreement on one particular product and application. Finally, let me just get to the main reason that we're here. We're looking to raise $10 million to fund. First, we're going to start small-scale toll production. That'll be relatively limited, with most of the $10 million is for us to finalize the design of our first manufacturing plant, put that up, and start manufacturing and selling. When we get to that point, we'll be at a profitable specialty chemical company and positioned to do another stage of growth, which would take the volume up to another factor of 10. And that would get us to our $20 million per year EBITDA figure. So with that, thanks for the warning for the 30 seconds. I appreciate it, and happy to take questions.
All right, thanks for the presentation. So yeah, we're opening the floor to questions. So if you have a question, just raise your hand and we will call on you in the order that you raise hands on Zoom, of course. Yeah, Julia.
Hi, Leo. Thank you for the presentation. I'm Julia with Convergent Ventures. I'm just curious to hear a little bit more about the performance of your emollients. I understand that they're bio-based and lower carbon, but would love to understand if it's more of an equivalent to existing products or if there is true additional performance, if it's a different formula, different types of molecules, and what is typically used in the industry.
Yeah, so thanks for the question. We've done sensory panels, and some of our prospective partners and customers have done sensory panels as well. And two of the products in particular, just as an example, show really good sensory profiles similar to silicones. So non-greasy, a nice silky, dry type feeling, good absorbency. those kind of attributes certainly compare favorably with silicones.
Thank you.
Great. So we do have time for one more question if anybody has any. Yeah, John.
Hey, Leo, good presentation. Just out of curiosity, since 10 million is quite a large chunk of change to go not just from 0 to 1, but 0 to scale here, how much funding do you think you would need just to accomplish those first two goals of getting that first production and initiating commercial sales?
We do have the ability to break that into two pieces. We could, with $2.5 million, we could certainly start our toll production and get into the market and selling at that level. Yes.
Okay. Thank you.
Thank you.
Awesome. Great. So thank you so much, Leo, for that presentation. Just be sure to put in your contact info if you'd like to the chat so people can reach out after this presentation. And with that, we will move on to our final presentation of the day, which is compact membrane systems. Apologies that we have been going a little bit over time. But yeah, anyway, whenever you're ready, please begin the pitch.
Great. Can you hear me and see my screen?
Yeah, so the audio quality does sound a little bit like it's far away.
Okay. Let me just quickly check then where it's picking up my microphone from.
How about now?
Yeah, that's much better.
Cool. Awesome. Thank you. Thanks for your time. So my name is Nick Renard. I'm Director of Carbon Solutions at Compact Membrane Systems, which I will be talking about today. So transport and power have already a solution to reduce their emissions by 20 to 40% by 2035, mainly through electrification and renewables, whilst industry is making virtually no headway between now and 2035, with only 2% decarbonization planned to be achieved in the same timescale. And effectively, heavy industry is the largest source of CO2 emissions without a clear path to decarbonization at the moment. CCUS is the only near-term options for at-scale industrial decarbonization, primarily for two reasons. Firstly, there's about 17 years worth of global emissions that are locked into the current infrastructure, which cannot be decarbonized any other way than by using CCUS. Secondly, even for new infrastructure, CCUS is required for years to come because new technologies that can decarbonize industries such as steel, cement, kiln processes, and petrochemistry won't be available at scale and at acceptable cost for at least a decade, as shown here in this IEA graph. Separation represents over 50% of the cost of CCS. Therefore, reducing the cost of separation is the critical step in reducing the cost of CCS, which is the key step in unlocking widespread adoption of carbon capture and storage. At Compact Membrane Systems, our technology brings the cost of CCS as low as $40 per ton with our current membrane generation, shown in the orange curve here, and under $35 per ton with our next membrane generation, with even lower costs achievable for applications that require lower output CO2 concentration in certain utilization applications. CMS provides the best point source carbon capture solution for the market, not just because it's low cost, but also because it's a low tech risk near-term solution. The platform technology is operating in the field today in an olefins paraffin separation and is using materials that have a well-established supply chain and is therefore this low tech risk near-term solution. Additionally to cost and low risk, there's a number of additional attributes that our technology brings that make it the technology of choice for a number of industrial applications. Firstly, it doesn't rely on solvents as our traditional technologies do, and therefore avoids associated issues such as permitting, emissions, regeneration, that certain industries such as cement and kiln processes really want to avoid because they don't want to operate chemical plants on their sites. It's not something they do now, and it's not something they want to do in the future. It's a low energy, fully electrified solution that has no steam requirements, which is essential for any plant that has limited spare power capacity or limited access to water or steam. And it is intrinsically modular and can easily be scaled up, but also down, which isn't the case for other solutions that rely on size for their economics and are therefore unable to address the many smaller and distributed streams that you see in certain steel and cement applications. And finally, it's highly resistant to poison. We've demonstrated the performance stability in the lab and in the field in highly poisonous applications. So what is the technology? Our core technology relies on so-called facilitated transport membranes. Basically, we have embedded active elements within the membranes that facilitate the transport of CO2 molecules across the membranes, thus enabling high flux at low pressure, which reduces the need for compression and reduces the amount of membrane area required, overall reducing the OpEx and the CapEx of the overall system. And leveraging our 20+ years of experience putting membranes in the field, we then package this in advanced module and system design that enable the membranes to operate at high performance at field relevant condition and not just at lab conditions. So we've seen a lot of traction across the board. This summer, we closed an oversubscribed Series A, which was our first dilutive round with big players joining us, such as GC Ventures. Thank you for inviting us to this event, but also Pangea, Solvay, Chevron, Technip Energies. We've signed customers for pilots and rigs across steel, kiln, oil and gas, and petrochemical application, and we'll be deploying our membranes to the field in carbon capture applications in the coming weeks. And we have partners across the value chain, from strategic supply chain partners to carbon management, as you see here on the right-hand side. This is not our first rodeo. I alluded to our 20+ year experience putting membranes in the field. We've done that across an area of industries. And this is a key advantage for CMS because it means that, one, we have a team that knows how to commercialize and operate membranes in the field. And we have the facilities that can do everything from deep R&D at the chemistry level to module manufacturing and shipping. And we actually currently produce about 1,000 modules a year on our legacy application. And we can leverage this to accelerate the development and the deployment of our systems. I've touched on some of the milestones that we've achieved in 2023. I'm not going to go through these again. Next year, we'll be generating field data in multiple carbon capture applications, and we'll be already developing our next membrane generation, testing that in the field. And we'll be raising our Series B. So we're interested in talking to investors, always interested in talking to more customers, especially in cement kiln, oil and gas, petchem applications, and partners across the whole value chain. And then finally, I know there's some public sector people in the audience. We're always excited to meet with some of you. There's some specific opportunities here that we're looking for public funding or public support for, whether it's small commercial pilot deployments, support developing our next membrane generation, support doing some CFD modeling for our system design and membrane sizing, and then some support on the DOE Hydrogen Hub that's happening in Delaware, and of which we're part of the overall project. So thanks very much for your attention. I hope you have come within 5 minutes, and yeah, I'm be happy to answer any questions you may have.
All right, great. Thank you so much, Nick. Opening the floor up to questions. Just raise your hand and we'll call on you as you appear with the raised hand. And this is the last company presentation, so last chance to ask questions. All right, so Alexander.
A quick question. Is your technology potentially applicable to other gases? So, you know, either specifically thinking like hydrogen transport and separation?
So hydrogen is a particularly tricky one. I'm trying to see if I have, I don't have it here. We do have a slides on other membrane applications that we've looked at. Hydrogen is one of those where we could do something. It would take a fair amount of R&D. Hydrogen is particularly tricky to separate. We're looking at some opportunities in the hydrogen carbon monoxide separation. But yes, there are other applications, but it's kind of not our focus application at the moment. If it's other CO2 separations, we have done some R&D, for example, on biogas applications, or basically CO2, CH4 separations. But hydrogen is definitely trickier.
Thank you.
All right, we have time for one more question. If anybody has a question and wants to be the last question of this event. All right, Paul.
Sure. Hi, Paul Garcia from the Air Force Office of Energy Assurance. Can you describe any relationships that you have with power producers?
Are you saying specifically power generation?
Yes.
Or oil and gas more generally?
Power generation.
So power generation is an application that we're starting to consider. If I go back to one of the early slides that I was showing on the costs chart. Oh, went too far. What you see here is that in a what we call pure play scenario, so if you're using membranes only, we're extremely competitive in higher CO2 concentration applications, so steel, cement, blue hydrogen type applications. When you look at power generation, which is much lower on the CO2 concentration on the feed side, membranes alone will struggle to be economically competitive. And what we're looking at in those scenarios at the moment is doing a hybrid technology approach. So you combine two technologies that are going to have specific strengths in different parts of that CO2 concentration range, and that overall can achieve the lower economics. So we're starting to look at that with some of our strategic partners, which I can't name because we haven't formalized the relationship around that. So yeah, that's kind of as much as I can say at the moment.
That's fine. I'd like to talk to you more about that.
Yeah, absolutely. That'd be great.
Okay, awesome. Awesome. It's a pretty good note to end this event on. So Nick, if you want to just put your contact info in the chat for the brief amount of time left that we have in this event, but nevertheless, so anybody can copy it down. And with that, I'll be wrapping things up. So thank you so much, everybody who joined. First and foremost, thank you to the companies who pitched, who gave really excellent presentations with amazing technologies. Thank you all to the panelists who stayed and stuck with us, especially since we had ran a bit over time, so I apologize for that. But thank you so much for staying and asking amazing questions and helping make this event a great event. And of course, a huge thank you to GC Ventures for co-creating or co-sponsoring this event and helping and sourcing the companies. They really did a great job with the companies and with the panel discussion in the beginning. So thank you so much to everybody. A follow-up for this event will be sent out by the end of the week. So the recording for this event will be sent out as well. So in case you want to watch this event, which I'm sure everybody wants to do, or watch a couple of presentations again, you will have that opportunity. So thanks again, everybody. It was an amazing event. The almost 3 hours flew by for me. So I'm really glad. I liked moderating this event, and hope to see everybody at some of our future events. So our next one is on November 29th. It's a Future of Computing themed event, and then the next event will be in late January. We're bypassing December because late December is the holiday season and everybody will be on vacation, I'm sure. So yeah, November and January are our events. January is on aerospace and defense, and looking forward to seeing you all there. And thank you, everybody. So have a good rest of your day, good rest of your week, and have a nice Thanksgiving also next week. And yeah, take care.
Thanks very much. Thanks for organizing.
Thank you. Thank you for inviting us.
Sure, my pleasure. And thank you for joining. And again, a huge thank you to GC Ventures. Thanks. All right. Take care, everybody. Have a good day.